So, welcome back, guys. And those who are watching us online, please don't forget to join the third link to continue our conference. Okay, great. So, the next topic we are going to cover goes like Web Security 101. And I'm glad to introduce you Carrie Maxwell, a security engineer from Crimson Vista Incorporate. And just a few words about her. Python was her first programming language that she self-taught herself when she was an environment scientist. When she is not at work, she is an MBA student and moonlights as a freelancer, but she has always time for civic hacking. So I'm glad to welcome here Carrie. Hi, Carrie.
Hi, how's
How
everyone
are you?
doing?
How's your mood?
It was pretty good. This is like my first time doing one of these online conferences, so
Yeah,
pretty happy.
congratulations. that is that's very sweet. Sorry for a long wait. We tried to connect the third link, but anyway, if you're ready and if you're ready to share your screen and presentation, so
Okay.
go ahead.
All right.
Yeah.
So let me just put this timer on,
Mm-hmm.
and I'm ready to go.
Yeah,
So,
we can see it.
okay. This is Web Security 101. I'm Carrie Maxwell. A little bit about me. I have my environmental science major from Notre Dame. I was a fencing champion. I used to be a web developer, and then I moved into security and I got certified. And like most other people that have been through this pandemic, I am now on the job market yet again. So you're wondering right now, why security? Why security talk at a React conference? I know some of you guys are like, only big companies get hacked, but these mistakes can be costly. So I want to introduce that to you guys. So one big thing I feel, this is what I feel personally, security is technical debt. You might not pay for it right now, but you will pay for it later. And that might be something simple as waking up or being missing out on something during a crucial time because you have to fix a problem. So, but there's organizations out there to help us. OWASP is a foundation that is here to improve security of software. They're a nonprofit and they have a lot of guides. One of the guides they have is the top 10 list. So here is the list of top 10. And we have injection, broken auth, sensitive data exposure, XML external entities, broken access control, security misconfig, cross-site scripting, insecure deceleration, using components with known vulnerability, and inspecific logging and monitoring. So out of all this, I want to cover 2, 3, 7, and 9, which I feel has purpose for React developers. So pretty much any app can be broken down by you have to use a web server, you have application logic and a database, anything that's not something static like Gatsby. And when you have this, you're going to have data involved. And when data is involved, you have data in rest, data in transit, data in use. They're all vulnerable at any given time and need to be secure. So my agenda for today is I want to go through some quick fixes. I want to also delve into passwords and also cover cross-site scripting. So you might be thinking, if it doesn't work, I don't have security vulnerabilities, but also that means you can't actually pay for things. So, and also people aren't going to pay, like your customers are not going to pay for an application they can't use. Also, if it has too many vulnerabilities, you might lose your customers. So moving on to some quick fixes. I'm going to start out with components and known vulnerabilities. As React developers, we are beholden to the NPM lifecycle. So one of the questions you might ask yourself, am I vulnerable to using components with known vulnerabilities? Perhaps, but you have to understand NPM has so many dependencies, and it only takes one to cause a problem. In recent NPM history, we had LeftPad, and LeftPad broke the web. It was a secure package, but since it was removed, it caused problems. So, ways that we can stop this from happening, like if they actually are packages that you or libraries you're using, you can always run npm audit in your terminal. You can wait for GitHub to email you, like this is a great new feature they have, and they tell you which repo and everything, or you can get a vulnerability scanner going, and there's so many scanners out there. Some of them are free, some of them are paid, but you can use them to look at your open source packages and find out which ones need to be replaced or discarded. So another thing that could help you out is implementing SSL. Secure socket layer, or also known as the new version, transport layer security. So any customer you have, let it be an older person or a young kid, can always see the padlock and know that their data is secure. But when you don't have it, that is the one security thing that they can look for and not see and know, hey, I probably don't want to give my money to this. And also some modern browsers actually will tell people and route them away from places that are unsecure and not using HTTPS. So I want to break down into the encryption side and how data is moving. So you have a site. Your site has all this data inside it. First, you encrypt it and then use some type of symmetric algorithm. It can be AS or anything else, but it goes through and it's decrypted, and then you have your site again when you're growing through HTTPS. This is the most simplistic way to say this. It's more complicated than that, and it has another part where the certificate that you have that makes the padlock actually has an authority that says, hey, you guys are legit, you're a legit website, and you are who you say you are, and that goes in between the client and the server and uses asymmetric algorithms, in most cases RSA. And with these two combos, it creates a handshake that gives the confidence for your customers. Moving on, sensitive data exposure. So it's just everyone's junior, so you make mistakes. So one thing is we can learn from others' mistakes. And one big mistake is leaving API keys, tokens, or any other secrets exposed. And some people will commit this to GitHub. As this table shows, there are all types of access tokens, API keys, secrets exposed on GitHub. And this is really low-lying fruit for hackers. So there is a way to actually hide your API keys and secrets. this person we found actually started having keys in access, but also they actually exposed their keys in GitHub. So it still happens. A way to avoid this whole situation is just use environmental variables. So you can create an environment file, make custom variables, hide your API keys or anything else that's secret, and then add those variables to your Git file. Also, you might have a node environment file too that you also want to hide as well and use that instead. But also, there are actually libraries out there like Git Secret and Git Secrets with an S, which also helps hide AWS files, AWS secrets, because once those get out, man, you're getting a lot of DDoS attacks, like denial of service attacks, and your bill for Amazon, I would not want to pay that bill, believe me. So another quick thing you can do to actually help you out in security is test often. So that can be unit test for just the code itself, or you can even delve into DAS and STAS, like static testing, like application testing, and also dynamic testing. And I like to remind myself of the testing burrito. I have tests I plan to write, the tests I start writing, tests I delete because I think they're stupid and take more time than they're worth, and we actually get some tests. And then we dip this Dorito into the salsa, which is pretty much this ball of salsa, which is your CI/CD pipeline. It also has static testing and application security testing as well, all automated. So you just dip your chip in for you as a developer, and you guys are just eating the success of testing. Delicious, but also hopefully that motivates you to actually write tests. So at this point, you might think, hey, this is fine, but things are better. I'm doing some of these things. But you might not know how big the dumpster fire of security you are actually sitting in. But no worries, we're going to move on, and hopefully you will get away from this dumpster fire. So passwords. Passwords are a big thing. They're a source, they're like number one data source, and you see them in form validation. So on this page, I actually have an example that actually broke today. So on Reddit, angry customers shared the email they got from a company that actually exposed their passwords because they had malicious code inserted. And that caused ripple effects that their passwords were compromised, but also their credit cards were compromised. And sometimes some of them even got their PayPal or Apple Pay compromised as well. So some of these folks have actually real implications. Like one person was charged $4,000 before they realized it. And now they have to get new cars and look out for like ID theft and all this stuff. And it's just not worth it for them and for these customers. So they're probably going to leave this company. And breaches have consequences. They can get fined, companies can get fined, customers leave, and it leads sometimes to layoffs. Or the company can just crumble entirely. So a big problem is having passwords saved in plain text. And to avoid that, you should hash your passwords. So instead of them having in plain text or clear text, you change it up and you do a one-way change. Encryption and decryption were two-way changes where you got your data back. However, in hashing, you keep the hash. In this example, I have "Hi, cool cats and kittens" as a possible password. But then it gets transformed by SHA-256 and becomes this hash. So if a hacker gets my information and gets my password, they get this piece of code. But that isn't, it's a great first step, but hackers are smart too. Unfortunately, in order to stop that and stop using the hash table, we have to season our hashes with salt. So a salt is like usually a string that you use to add it to your password. You can do it before or after. Most people like to use it before, and it just changes the hash so it doesn't line up in a hash table. It stops most password-based attacks, so you're not going to be subject to a dictionary table or a rainbow attack. So it just stops that. So I have some password tips that we've covered, and some I haven't. So as I mentioned before, we want to avoid plain text and clear text passwords. We want to use two-factor auth. We want to be careful with error messages when we're actually submitting passwords in to validate them, because hackers can see that and start to guess. Also, we want to season our hashes with salt so they avoid being in like our passwords stop getting implemented in dictionaries, and we don't have hash collisions. We don't match up in a table. We don't use MD5 and SHA-1 anymore because these are unsafe and also very short. When you're using an algorithm to hash, you want to use something that's long. So that takes time. I know that goes against software. You want everything fast, but the longer it is, it's going to be harder for them to break it. That's why you use long passwords, and also use a CAPTCHA. And usually hashing is best used on the server side of things, because if it's on the browser, they can easily go to developer tools and somehow finesse and get the hash or just the password itself, depending if you didn't hash your password. So I want to move on to cross-site scripting. It is a big deal for React. There was actually a CVE release for it. So it's a problem React has. Usually when we use React, we are rendering a lot of data with render. However, when we're doing this, React is set up to be safe for us, but there's ways that we get away from the safeness of React and shoot ourselves in the foot. So I just want to explain what a cross-site scripting attack looks like. So you have an attacker. They send some script linked to the victim, like an email scam. They click on it thinking that it's your website and, oh, I'm so excited that I'm going to spend money on your website. But it loads the legitimate site, but also has the malicious script similar to that incident I mentioned in passwords. The malicious script sends the victim's private data, which would be password, money, any monetary things like credit card, PayPal. Depending on the type of form you're using, that can also include like their social security number, where they live, just things that would upend their life. So it is in our best interest to have happy customers and avoid this. So in this example, we have an example using React. So our user input is defined in a div, and we allow any type of user input. So any type of string. We're not validating, we're not sanitizing anything. So because of this, you can get anything. Like in this example, I have hi, image search, error alert 1. Or error alert 0. So you can get 0. Like if you run this, you'll get 0. That might not be any concern to us right now, but if this person had malicious intentions, like in this case, we have user input, but hi React, and you decide, yes, it's going to escape. In the previous example, React would escape the image because we didn't use dangerously set inner HTML. But in this second case, we don't have any escaping happen. So you have, hey, hi React, and that would be a successful point of user input. But if we have hacker input turns into user input, I'm the bad guy, duh. Image search error 0 alert. This will actually come out to 0. In the previous example, it will not because React escapes in a way of sanitization of our data for our inputs. But because we use dangerously set inner HTML, we're avoiding all the benefits that React has for us. So we have to go out of our way now to prevent this from happening. And there is a JavaScript library out there. It's called DOM Purify. And this is how you can implement it. So you can use dangerously set inner HTML. I wouldn't advise it. Don't use it unless you have to. But with DOM Purify, it takes that input and gets rid of that bad guy with their alert that's going to be all bad news, and possibly, in another case, a malicious payload that could steal your customer's data. And DOM Purify gets rid of it, and all you're left with is I'm the bad guy, duh, and look at them. They look really dumb because they weren't able to run off with your data. So, some key takeaways. React naturally escapes with JSX. Don't use dangerously set inner HTML if you can help it. Don't trust parsers because parsers may work for HTML, but they will not leave, and they won't get every single thing out to sanitize. DOM Purify is a better and a more standard way to sanitize your inputs. And here's a big way to shoot yourself in the foot is after getting that user data, if you transform it in another render or something else that modifies it, you can negate the positive effects of sanitizing your data. And also try and don't directly inject data to the DOM. So in conclusion, we went over broken authentication when we talked about passwords. We also talked about sensitive data exposure. We talked about cross-site scripting and how it looks in React. We also talked about using components with known vulnerabilities. So we learned a lot today. And I know some of it might be confusing, but each one of these topics could be their own talk. And this is just the surface layer of everything. So now I hope you can confidently move away and walk away from any dumpster fire you have with your customers' data intact. Also, if you're hiring and you like having your web app secure, hit me up. on LinkedIn or email me. You can email me at at cdmaxwell@gmail.com or on my Twitter. Also, here's some resources because I know I went through a lot of things quickly and you might actually want to use this stuff, and I want you guys to actually implement this stuff. And that is pretty much the end. But also, I really can't mention one little thing, injection. SKDC, I can't leave without it. So if anything, Bobby tables and sanitize your inputs. Okay. I'm like, I can't hear you right now. I can't hear you, Anna.
Вимкнути. Ага. Okay, can you hear me?
Yes, I can hear you now.
Yeah, great. And Carrie, I've noticed how much of effort and work you put on your presentation, and those ma'am, they were great. So thank you very much for presentation. And if this was your first speech, then I just can imagine what is going to be your next. So please, thank you. And see you later on Q&A section.
Okay.
Okay, bye.
Bye.
And we have our next speaker waiting for him, his prime time. And the next topic is going to be amplify your audience. And Gert Laborde from Infinite Red is going to cover this topic. And just a few words about him. Gert is an owner of Infinite Red, mentor, adjunct professor, published author, and award-winning speaker. He is recognized as a Google developer, expert in web and machine learning. But informally, he is an open sourcer and aspired to one day become a mad scientist. So, hi, Gert.
Hello. Hi. What
How are
time is it
you?
over there?
Sorry?
What time are you over there?
Actually, it's 6:45. So,
Oh, wow.
yeah, I'm an early bird.
Oh, good. Yeah, it's I'm over here in the States.
Uh-huh.
And it's about to be 11 p.m., which is, what would y'all say, 2300?
Uh-huh.
So it's fun. Yeah.
Yeah,
Across
it's
the
fun.
pond. This is travel now, right? This is what we do.
And I have one question to you. So,
Okay. It better be good because there's only one.
no, but on Q&A session, we will have a lot of it.
Okay, good.
So one question, like you said that one day you'd like to become a mad scientist.
Yes.
Yeah, but mad means like those of mad scientists that's gonna destroy all the world and humanity in general. Are you going to be one of them?
I think I'm going to do something ridiculous. So a few mad scientists give the rest of us a bad name. Okay, you make one death ray gun, or you try to blow up the moon once, and now all mad scientists are terrible. That's just something that we're going to have to continuously work against, and that's why I'm doing presentations to help people out, knowing that we're people too, and we might do something really nice, like make pumpkins that come to life, or reanimate people, or make an ice or a shrinking ray, like Honey, I Shrunk the Kids. That was a mad scientist, and it was a good mad scientist.
Yeah, actually, yeah, I can agree with you.
See, this is all part of it. Like, I mean, I want there to be unicorns in the world. And like we just need the right mad scientist and the right GMO stuff. Which, like, whatever, we can split the genes and we'll make some unicorns. Let's have fun.
Yeah, I definitely agree with you. And if you're ready, if you're ready
Sure.
to share your screen and to share your precious knowledge. Go ahead.
Yeah. All right. Excellent. So, hi everybody. How you doing? I'm going to go ahead and do some screen sharing here. There we go. I believe everybody should see the screen now. So I hope that you're all ready and you're excited. Let's have some fun. I know it's early there and late here, so I am telling you now, I am going to depend on just a little bit of energy from the audience. So I've pulled up some of the comments there, and you know what? I'm going to go ahead and pull up the live comments as well. So wherever you're saying something, go ahead and talk to me. Say hi. I actually want to see the comments because I plan on interacting with you. And that's going to be the interesting part of what it is that we're doing here today. Okay. Wow, that was really good. Should I do it again? What? This is live? All right, guess we just roll with this. Okay, so let's have some fun. Who the hell is this guy? First of all, you know that I'm saying that I'm a mad scientist, right? We've got that much. So let's talk just for a moment here. So, hey, Gant Laborde. I am from New Orleans. I am from the States. Yeah, that's a weird place to be right now. Those of you who are here that know all the craziness that's going on. I am a CIO of a wonderful company called Infinite Red, and that allows me to be the chief innovation officer and build cool stuff. I also, I really love JavaScript. I know. It's some of you fainted. Some of you are thinking I'm a liar, but I think JavaScript is this unifying language that connects us all. And it's just as confusing and elegant as people are. So it's actually a great language to sort of bring all these different frameworks and collections of people. So I build mobile apps in React Native as well. So I do a lot of JavaScript. So core contributor to React Native. The reason I bring that in there is because I want to build awesome things and I like to use it in JavaScript. And then one last piece of this is that, yes, I am a Google developer expert in both web and machine learning. So I'm going to glue some of these things together for a fun chat for us today. And we're going to check out some pretty interesting stuff together. But I want to say I am doing a giveaway. So I'll be giving something away during my talk. So be sure to follow me on Twitter. If you go on Twitter, it's Gant Laborde on Twitter. And so the advantage that you'll have if you follow me there is that I often give stuff away. Sometimes it's shipping only inside the US and sometimes it's international shipping, but I'm always giving stuff away. And another piece of this is that I am also constantly posting silly things about React. I just posted a really awesome blog article about shipping React Native apps and fun other stuff. So I also give away a lot of really cool stickers. So if you see any of these crazy stickers around, that's me. That's silly icons. If you go to my GitHub, you'll see quite a few of this. And it's a bit of fun. So you'll see that on Twitter as well. So here, let's go ahead and let's talk about, I think it's early. Let's talk about some cool things in technology, right? Let's just dig in a little bit here. We want to talk about React. We want to talk about cool things we can do. Because who said I wanted to get into programming so that I could make a packing list or a to-do list app, right? No, none of us said that. Or who wanted to get into programming to optimize a sorting algorithm or something like that? Very few of us. It's interesting. And stop making fun of me because I did. So what cool things are there out there in technology? Well, for this conference, right, for what we're talking about here, I think that React is sort of like that extra level of glue, grabbing all these cool things and then making them accessible for us. For instance, we're talking about React, we're talking about JavaScript, right? And who says JavaScript isn't cool? Look at that right there. you can read that. Everybody can read that. That's perfectly sane JavaScript. And if you copy and paste that into Node, it prints out my name. So I'm pretty proud of that. It doesn't make any sense that you should do it. But what a glorious language that would print out my name. This is 100% true. So what kind of stuff have we done with that? And as a company, one of the things that we do is we take that JavaScript and we build two things: websites and mobile apps, right? Because that's sort of like the exciting access of, I want to build an application here. And so, like I said earlier, we use React on web, we use React Native for the mobile stuff, and just kind of sharing that mentality. It's a lot of fun. And then writing JavaScript with your friends is pretty much, it's like a self-help group. You kind of need, some anonymous people. You show up, you're like, hey, Gant, like, yeah, longtime member, I've been writing JavaScript for 5 years, and we all support one another. But it also gives you access to cool other things. What other cool things do we have? All right, buzzword, right? I'm hitting all the buzzwords. Y'all like it? Don't forget to make comments. I want to see more comments. What cool things? GraphQL. All right, GraphQL is pretty awesome. Now, one thing I'll say is that not enough people are using it, so you get all excited about GraphQL, right? And then a client comes along and they're like, we already have an API. It is a RESTful API. Damn it. So, it's always fun, but we have, if you're not familiar with GraphQL, it's sort of like API as a menu. You have a schema, that's the menu. And then I order off the menu, because this is the junior track. So forgive me if I cover something you really already know. But if I want this information, this information, this information, I order that off the menu. The server gives me exactly that information back. Sounds like it should have been what API always did, but for some reason, due to, I'd say, probably academia, it wasn't. So sure enough, okay, fine. So now we've got cool things, but we've got even cooler things. So you can get GraphQL subscriptions. So I used to have to poll with JavaScript over and over again, trying to figure out when updates happened on a server so I could do cool stuff on my side. Well, no, now you have GraphQL subscriptions. I can kind of like get this real-time access. I feel like I've got this, like, they've got this WebSocket open. I can really do some cool things, which, spoiler alert, we will do. So what have you done with things like GraphQL and stuff like that? Funny thing is, we have a game we play at Infant Red called Who Said It, where we quote people out of context. And they don't know that we've put a quote that they said into an app. And then later on, we randomize them and make everybody guess who said what. And then I wrote a mobile app with that. It's using GraphQL. It was really fun. Basically, just all leaning on GraphQL. Really cool stuff. And the third aspect for what we will be talking about in the crazy mad scientist world that we're doing today with the secret order of awesomeness, we will be doing some AI machine learning. Ooh, yeah. Buzzwords. I got them. I've got them. And that sounds like, some of you would be like, yeah, please. I don't want to hear any more about AI. I promise I'm here to make it as painful as possible. Oops, Freudian slip. It'll be fine. Just come on in. It'll be great. So AI can run in all kinds of different great places, but here's some cool stuff that we're going to do. AI can run in the browser. So now we're hanging out with React, right? We're getting some cool stuff happening there. So what kind of stuff have you done? With AI stuff, we've done some pretty cool things. I'm not allowed to mention some of the companies that we've done work for, but we had this one client who asked us to do AI makeup transfer in the browser so that people could try on different types of makeup immediately and then go over there and press the purchase button, receive their makeup. So they get this professional makeup done instantly. And one of my favorite parts about this is that our friend Leon was working well into the night. And so he would constantly send these pull requests with the work that he's done. I think he really enjoyed it a little too much. So we had some cool stuff like this. It was a lot of fun. So, all right. That's hopefully scratching a little bit of the nerd brain for everybody. Like, I hope that nerd brain stimulated. We talked about React, we talked about JavaScript, we talked about AI, and we talked about real-time updates with GraphQL. And so I wanted to come up with a project, and it took me 10 years, and it took the world 10 years to come up with how we can build this at home. When I saw this, it was state of the art, awesome stuff. So back in 2010, yeah, I know I'm old. I got gray hair and a gray beard. All right, I know what I'm talking about. In 2010, I went to Universal Studios, and they had this really cool thing where they would sit you in a room and pay you 50 US dollars to watch pilots and commercials. And when you're walking around in Florida, it's pretty hot, it's very hot. So what I did is I went in there and they handed me a green bar from my right hand and a red bar from my left hand. And then as I was watching these commercials, I was supposed to squeeze the right bar when I liked something, and then I was supposed to squeeze the left bar when I disliked something. And so here I am watching, ha ha ha, oh, ha ha. And I thought to myself, this is genius. You're instantly getting feedback. You can grab this data and then you could find out immediately like what I actually was thinking of how that joke landed. And then you could get all the data from all the people who've watched this same exact episode for my demographic and then see how good that show's actually doing. This is such a cool thing. And I said, one day I will try to build something like this. And it's going to be amazing. And I didn't know anything. And plus, I can't solder at all. I've tried. I break things. So let's take a look at the timeline of events that have happened since then. So in 2010, Gant goes to Universal Studios, discovers this really awesome device. Something happens in 2012, unrelated to me. ImageNet starts to get GPU entries. So AI starts to really kind of step things up. And people start getting the machines that can actually do these cool things. So we have these cool machines. We have these really cool, like entries into figuring stuff out. Machine learning starts to grow. In 2013, yeah, I know. Facebook releases React.js. And so we get the public version 0.30. In 2015, AI starts to actually surpass human capabilities. So now everybody is starting to put funding into this. You start to see Google and a bunch of other major companies actually start to put money, time, and energy into this AI boom that starts to hit right along this decade that we're looking at. In 2015, we get the first draft RFC for GraphQL, which is really cool. Then in 2017, Amazon announces this thing called Amplify. And the Amplify CLI is sort of like helping you glue all kinds of AWS services together. Now, if you're like me, AI sucked and you were afraid of it. And also, let's be honest, in 2015 and around then, AWS services were really hard to wrap your head around, comprehend, or even use. Like I used S3 hosting, right? For every mobile app and everything we needed. And then when it got beyond that, I was just like, hey, that's your task over there. You had to do all these really complicated things. It wasn't very easy to understand, but now they're wrapping services around it like Amplify, and things are getting easier and better, especially for us React developers. If you're a junior React developer and you're coming to this brand new, kudos. Like you're lucky. You don't have to. You're just hearing about how I walked to school every day, uphill both ways with people shooting at me. Like I understand this pain is not yours now, right? And then in 2018, we get TensorFlow.js, which lets me run machine learning directly on the browser. So I don't have to host something. I don't have to have like a server running that everybody can clog up and kind of ruin. I can actually send machine learning to your browser and then have it actually run on your machine. Ooh. And then in 2018, we get some stable GraphQL. So the past decade's been really awesome with technology. We really are existing during a time where we've seen developers really grow and flourish. Let me know, by the way, in the comments on this technology, what do you know a lot about? And what do you know very little about? Are you a GraphQL guru? Do you know everything about AI? Are you just brand new to all of this and you're kind of like looking for the bigger concepts? Because I'll adjust this talk a little bit, ever so slightly, to match my audience. And the problem I have is that if you don't send those comments, I kind of have no idea whether or not I'm connecting with you at all, And so that makes it difficult. Because what can we build? What can we build? Well, that's actually a problem that we have right now. Like we can't talk to one another. I have no idea if you are able, or if you're even like enjoying my jokes, right? And that's something I think all virtual conferences have felt. But we could fix that. We could fix that right now. You see, as an audience, you have webcams, right? Most of you have webcams. What about the idea that over in your webcam, we put just a facial detection model, right? And then the facial detection model lives on your machine. That way, I'm not getting a picture of your face. I don't want to look at your faces. I don't want to see any of that stuff. It's okay. You don't have to do that. And then on your machine, since it's looking at your face, it can kind of detect some basic things like, let's see, maybe we could detect if you're smiling. Maybe we could detect if all of you are absolutely disgusted and hate everything that I'm saying. I would like to know that too. So maybe we could actually see and just get on your machine, not for me, what your emotion is one way or the other. So in React, we can make websites quite easy. That's no problem. We can just create a React app. And then if I can get some data, because what we could do here is maybe I can get that information over and then turn it into a chart. So maybe 50% of you are smiling and 50% are neutral. You don't care at all. I guess I can kind of do that pretty easy in React. And then as a person's asked, a little bit about GraphQL for a second, we can use Amplify and we can get that information in real time, right? We can actually use AppSync to tie all this together, you have your machine say, hey, I'm happy or I'm sad. Then all of your machines using that React app send that together to Amazon Amplify through a GraphQL server that would be hosted. And then we can keep the data inside DynamoDB. So we can use all of that technology we just talked about. Maybe it wasn't random. Maybe he's not mad yet. So how about this idea? Nothing to do with actually watching your faces, but a machine watches your face. And then it tells the server happy, sad, whatever it is. And then I get all the information brought together inside of a service in real time. And then we get to see how we're all doing. I think that would be really cool. I think that's what we should do right now. So I know it's crazy different times wherever everybody is, but I actually built this and it's using all that technology right now. Now, don't worry about it if you don't want to participate, but just remember, I'm not storing any of this information permanently. You're 100% anonymous. And the idea here is that me as the speaker, let's kind of see whether or not we can actually see how the audience is doing. Y'all ready for this experiment? Let's see. So the URL is enjoying the show with enjoying the dot show /room/demo. So we are going to hopefully see, just go ahead and go to enjoying the dot show /room/demo. And I know that we're a little bit on a time delay because this is going through StreamYard. So just imagine that we're not going to see everything in complete awesomeness real time right now. As a matter of fact, I wonder, I know I'm using my webcam right now, so I probably can't join the room myself. But if we can get people to join that. Now, first thing that happens when you join is it will politely ask you, can I have access to your camera? And you will have to click yes. And then it will show you a bounding box around your face, telling you what it's sending to me as the server. So you can make different faces, happiness, sadness, and many other things. And then I will see that. So now I'm going to show you what I'm looking at. So let me go ahead and get this down here. And then I see that there are some people already in the room. So do me a favor. You can see a bunch of happy people. This is fantastic. I'm glad we have people who are happy. And then we can see that most of the people are happy. Oh, somebody got sad. Yeah, probably one of my jokes there. And so as you are making the faces, I am real time. So even though we're on a delay, this is showing to me in exactly real time. And I love the expressions of faces I'm seeing. Someone actually did surprised. Give me some more surprised if you can. I definitely want to see some more surprised. Yeah. This is somebody's giving sad and angry. It's of course depends on your lighting. It of course depends on a bunch of other things. But if I were talking during this talk, it'd be fantastic if we had a real time and I get this. I get to see that dream. It's happening right now. I am able to actually connect with my audience. So I just wanted to say thank you. This is awesome. And by the way, you're not going to crash the server. It's AWS. Good luck. What are you going to do? I've got there's like 32 people currently who voted in and said they're happy to do this experiment. Super awesome. I know there's plenty more people watching. But what I love about who did fearful? What I love about this is that this can support thousands upon thousands of people if we really wanted to. So this is a gift. This is a gift to you. If you would like to, and I'm sorry I'm scrolling off, y'all can continue to have fun. You can actually watch this room under enjoying the show, change room to watch. And actually you could set up 2 different browsers and then just send data straight to yourself, right? Because it'd be a lot of fun. So I'm going to go back to the main page here for a moment. And I'm going to let you know, this room was called Demo. And you can use this forever for you as long as we host a site. I'm totally happy for you to use it. You can create a room right here. You can name it, let's name this one Nachos. No one should be in Nachos. Please don't go to Nachos, or you can if you want to. And then you get this nice room. This room is empty. There are 0 people in this room. And then just share this link to them, the room for that. And then that'll send that expression. Any conference that you're at, have fun with it. There's no ads or anything silly about this. This is just a gift to that person and that sort of scientific natured energy from 10 years ago in real time magic. So you can create your own rooms and such. Thank you for that experiment. And so let's get into some code, I guess, right? Let's kind of take a look at some stuff here. So just as a heads up, I have a little video in case everything failed, but everything worked great. So I don't have to actually show that video. And then we can look at some of the code. And I am going to warn you, this code is so clean that you might not feel like you could ever code again. It's too good, and I totally accept that you will feel sad after seeing the cleanliness of my code. That's a setup. This is all trash code. I'm sorry, and it's open source, so please help me. So let's go take a look at what's happening over here. So I'm pulling the code up, and let me just kind of get this just a little bit bigger. We can take a look at what's going on here. Now, I would love to answer everything that you have. Save it, I guess, a little bit for the Q&A, because we might need to come back to this in a certain degree. But if you have some questions, you can kind of ask them here, and I'll try to show. But with the delay and everything, it's going to be a little difficult. So what I did is, if you take a look here, I have your classic old Create React app. This is just a Create React app, nothing too fancy. And then inside this Create React app, I have that main page which creates or destroys, or creates or goes to a URL for a room to watch it. Now here, inside the room, where we're going to take a look, we can kind of take a look at what's going on here. We start off with, we have the room, and then we load the models and all. That's very technical to be said there, right? Load the models and all. When we're loading the models, if you're brand new, and I saw some of you said that you're brand new to machine learning, a model is super fancy for a function, right? So all we're doing is we're loading the models to detect and then identify faces. So we just kind of kick that off as soon as you join in there. And of course, we've got some, hey, don't worry about it. You know, you need to actually be able to run this stuff. So we make sure we can actually see your camera. So then we turn on your camera and we start streaming that stuff through the function, through the model that looks at faces and then determines the sentiment of your face. Did I lose anybody? This is like awesome, easy. I know the code might look bad, but I mean, you're following the logic here. I turn on your camera and I stick it through the model. So we're just we're checking that out. And then we detect face stuff. Again, very formal. And then as we're detecting the face stuff, I'm mapping over. Oh, I heard myself for a second there. How am I hearing myself? Ooh, something's blowing me away. Hey, I'm going to take my headphones off for a second here to see what's going on. I think I did this to myself. My apologies. All right, I'm taking my headphones off because somehow I'm hearing myself. It must be somebody who's kind of going through here. All right. So now I can't hear myself. And so as we're kind of digging through this, we are able to detect all the faces inside the camera. And then we go ahead and we get those emotions and we set them up. And then all we have to do is, once we've got that emotion, let's see here, this is activating the person in the room. Let's see, take a look at this. Set emotion goes to the server and just does this this amplify call. Pretty straightforward, right? So what we have here is we say we've got a query what we're calling update room, and we take your randomized ID that you are, right? We're not keeping track of you. You have a random ID, and then we say, oh, the room's updated here, but we say, take a look at, this is update audience member. Sorry about that. Having the audio messed me up. And then I just send your emotion to the server. That's it. So I send your emotion to the server. And then over here on the GraphQL side, I also say the room updated. Then the thing that we're watching on the other side has a DynamoDB subscription that just watches for updates to people as they're kind of going through there. And then so now we can actually watch, as this room opens up, we subscribe, and then we fetch the emotions for a particular room. And so we say, okay, we want to get the emotions for this particular room by the name. And then we get that and we put it inside of a victory graph, and we just watch it animate away. I don't think there's anything really that you've kind of lost from this. It's not any kind of difficulty. I am abusing the magic of GraphQL subscriptions and the awesomeness of open source of Victory charts to get all these cool things and glue them together. And I think that the cool part about this, and I see lots of cool questions about TensorFlow in the chat, is that there are new cool models every day besides facial recognition and sentiment analysis. And what I love about this is that tomorrow they're going to come out with something new and cool. Like you can cartoonize people or do something else. And then we could all just hook this up together and then create the exact same thing in a totally new spectrum. If you're not familiar with GraphQL, then just pretend this is impressive. But if you are familiar with GraphQL, then yeah, the schema is super simple. I have an audience member and I have a subscription that finds, and then I have a room. Audience members go into rooms. That's it. Yeah. And then we have the subscription that updates me. These three parts. My GraphQL schema is 24 lines long. So just to give you a bit of a tidbit here, this is amazing. And I could talk about Amplify and all the cool features that it's allowed, but you've probably already seen quite a few talks about Amplify today. And I would say happily, we should check out some more of that stuff sometime. Let me see, how am I doing on time? I believe I have some more time here. So let's go ahead and get back to some of the stuff. And I promise you, if you actually would like to talk more about this code, or if you want to talk more about the data science, or if you want to talk more about the AI, or if you want to talk more about the React, please, the React needs some help. You can see that, right? I would love to get some help. And Hacktoberfest is coming up, right? Hacktoberfest, you need to get 5 commits. Come help me clean up this code and get yourself a cool shirt from Hacktoberfest. So yeah, I could use your help with making this even cooler. So let's get back on track here. Let's see if I can pull up a few things. All right, there's that. And then I will pull up one more. All right, 1 second. Aha. And then one last thing I need to pull up here. All right. There we go. Is this the thing? This is the thing I unmuted. I knew it. I pressed a button and I just completely destroyed myself by hearing the broadcast coming back. I was enjoying my own show. Okay. So let's kind of round this back out here and sort of see the end. Let's review what we just did. Okay. AI goes into JavaScript now. So you and all the cool tinkering things you have, you can go all the way to the edge in phones and in websites. I didn't have to worry too much about the server because all that device for your facial recognition was run on the browser right by you. You got the information, it was sent back, and then I had AWS report and perform other actions. That's what enjoying the .show does. And so I think it's really cool. I did do a blog post about this. And so if you want, that's the blog post. I'm going to share these slides afterward. So you can actually, from that blog post, see the story, find cool things to share with one another, watch more demos, and then I guess like also reach out to me if you want to kind of help out with other stuff. But the cool thing I really want to hit on here is that I've already thought of way too many other ideas and applications for this, and you should be building that. So for instance, like home security, I could use this to have all my cameras. It could be like, hey, we recognize someone who's not you went into your office, right? And then it sends you like a text message or Twilio, or takes a picture of them or something like that. Or maybe you train the AI to see if your garage door is left open and it's going to rain soon from the forecast. And maybe it needs to go ahead and send a signal, automatically close your garage door. Just cool stuff like that. You could use this for fire detection. Over here in the States right now, there's a huge problem with fire over on the West Coast. And I think it'd be amazing if, as many eyes and people there are out there, it'd be great if we had like a website and devices that could point an old iPhone out somewhere, or just kind of get some kind of fire detection or detecting poachers or some other kind of danger. And then all that AI information collaborates back into a single control panel. And then you could do cool stuff with sports and games. You could have multiple cameras watching how people are playing and all kinds of other cool stuff. I would love to chat more fun ideas of this. And I think it's a lot of cool stuff. But if you're brand new to AI, I say, hey, definitely check out. I have a free course that you can grab right now. Oh, that's awesome. I actually really like some of the stuff that y'all are posting. There's a really cool thing that you can get here. Free 5-day course for you to go ahead and get a little accreditation to learn some basic AI terms. That's something that we made for free. So I think that's really cool. And people generally seem to like it quite a lot. You say Gant. Of course you say people like it. I don't believe you. How the hell do you know people liked your course? And I'm going to tell you the answer. I asked AI, because just like this, you could apply the same sentiment analysis to text. So I just loaded all the comments to my course in a giant spreadsheet. And then I asked AI to rate it between 0 to 1, how much people actually, like how positive or how negative the comments were. And they were overwhelmingly positive. And the negative ones were mostly false positives. So, or false negatives, technically. So yeah, people are really liked it, and obviously using AI for sentiment analysis, I've just taken it and made it ridiculous. I just want you to know, I actually do read these messages too. I'm not a jerk who puts everything through AI, so I don't have to talk to people. If you make a comment in the course, I promise you I'll read it during my morning cup of coffee. So it's been a lot of fun. It's got over 4,000 people who've taken the course now. So I love building these cool things. I love building them for companies, and I love building them for conference talks, and I love doing that stuff. And I want you to build your cool thing too. Send me your ideas. Send me some of the stuff that you want to build. I actually had somebody reach out from a previous talk and say, can we build this? I said, that's a great idea. And we built it. I don't cover it in this talk, but we can go into it in the Q&A or a bunch of other fun stuff. And then I definitely reach out and chat with me on Twitter. Like I said, I'm going to do a giveaway. I did a library called Not Safe for Work JS. That's its own talk. It's a really good one. But I have this shirt, Not Safe for Work JS. I'll be giving that away on Twitter immediately after this talk. So be sure to follow me on Twitter, and it goes to, we'll be giving away this shirt. If you need a little bit more, of course, Fun Machine Learn is a Twitter account that I manage. The hashtag's doing extremely well. I'm not sure why, but it's a pretty cool Twitter account as well. It's almost as cool as mine. And I take all the things from there if you're a newsletter person, and I do this thing called AIFYI.com, where I just kind of post really interesting things like conferences like Talking Here and a bunch of other fun places that I like to go to and cool stuff. So I'm in this because I am a nerd. I'm in this because I think these things are cool. And I'm in this because I want to connect, empower, and get people active in AI. And I want that to be you. So thank you, everybody. Amplify your excitement, amplify your projects, and ultimately here, amplify your audience. Thank you, everybody.
Jen?
Yes.
That was insane. Like
that was fun.
Fascinating to listen to you and to see you. And seriously, you're so passionate about what you are talking about and what you are doing. Seriously, it deserves a great appreciation. And
thank you.
I don't know. You have all chances to become a mad scientist.
Yes.
If you're not already.
Yes.
Seriously.
I can feel it happening now. It's just mad scientist powers. Sorry, I
And you can
apologize.
never mind. Our viewers like it so much, and you can see it by yourself. How many compliments you got? Seriously, our
Thank
viewers
you.
adore you already.
And it's really fun. Now let me tell you a quick story about this. Testing that out, like alone, I looked crazy. When I was first working on this, I was at an airport once when I first started kind of working on this, and I was looking, I was like, and I was like, I'd forgotten people could see me. So
Actually, I can understand you. Like it happens quite frequently with me. With such crazy ideas, but I know for sure that they are not so crazy as yours. But anyway, like, so Jen, like, you are amazing.
oh, thank you. I appreciate it.
See you again on our Q&A session.
Absolutely. See y'all then.
Yeah. So, bye.
Bye.
See you. Wow, that was so great. Okay, like I needed time to to start a new topic. And by the way, I have seen one question regarding like our StreamYard and conference. So Trust Hour asked why part 1 private already. Okay, so actually, I know that physically it's not important or it's not like possible to watch our conference 24 hours in a row. Like, okay, it's possible, but with Red Bull and some illegal stuff. So you have an opportunity to watch all the junior like recordings on our webpage. Like you can buy it just for $15 and have all of them. So if you missed first part, you can like use this opportunity. So the next speaker is going to talk about making your React apps perform at scale. And Milecia McGregor, she's a senior software engineer, is going to cover this topic. And just a few words about her. She worked with JavaScript, Angular, React, Node, Python, Net, Azure, and so on. Like, bless you, great. And she also has a master's degree in mechanical and aerospace engineering and has published research in machine learning and robotics. So, Milecia. Hi.
Hi.
Can you hear me?
Yeah, can you hear me?
Yeah, I can hear you. Like, I'm so like fascinated and curious about your speech because like you seems to be a professional and you know so like a lot. So please tell us when you are ready to share your screen and to start your speech.
Okay, I'm ready to start. Should I just hit the share screen?
Yeah, I can help you with this.
Okay, I guess, can you see my screen?
No, unfortunately not.
Let me see. What about now?
Yeah, I can see it already.
Okay, let me go
Here.
ahead and hide that.
So I'm leaving. I'm disappearing and giving you more space for your for your presentation.
Oh, okay. We're starting now. Got it. All right. So, hey, everybody. My name is Milecia McGregor, and I'm a developer advocate at Conducto, where we make like really cool CI/CD pipeline tools. There's no YAML, by the way. But today/tonight, I'm going to be talking to you about how you can make your React apps more performant at scale. So this is nowhere near as cool as Gant's talk was, but hopefully it's something that you can take back to work and use it to impress everybody around you when you make your React apps move a lot faster in prod. So I always like to give just kind of a quick overview of what we'll be going through so you kind of know when to pay attention and when it's safe to zone out. But we'll talk about what it's like setting up your initial React app. So that beautiful create React app npx command. We'll go through that so you can see how things evolve over time. So that's kind of the problem with React apps. Nothing is static. Components are never set in stone. Props change. New APIs get introduced that you need to call. And there's just a lot of things that build up over time that you have to watch for, be aware of, and just generally pay attention to. So I'm gonna be brave tonight because it's like way past my bedtime, but I'm gonna try to do a little bit of live coding so that I can show you some of the tools that we use for testing React apps for performance issues in the first place. And then we'll go over a few tips of how to keep your apps performant. So that'll be more live coding, maybe some references to a few things. And then the fun part, we'll talk about cleaning up an existing app. It's really easy to talk about how you can make a performant app and how you can keep one performant, but the real work comes when you have to go into an existing React app and there's folders everywhere, there's duplicate components in different places. So it really helps to have like just a few tips on how to clean those up. And finally, we'll get into some key takeaways. So let's get started. This is the fun part. So I'm going to start with some code that I know for sure works because it's just the create React app. Like when we look over here, just in our directory, I'll try to make that a little bigger, but basically this is our shiny new project. It doesn't have very much of a folder structure. There's just some really simple stuff happening so that it doesn't render a blank page when you run the app. So right now there aren't any complexities like API calls or state or props being passed around. It's just a static page. And again, we have some CSS files. Who uses that in React anymore? Styled components all the way. And yeah, we just have all of the basic boilerplate create React stuff. So we know without a doubt, this performs very well. So I'm gonna go ahead and run this just so you can, I guess, see the difference in performance with a starting React app. So jumping the gun a little bit just to give you kind of a benchmark of how things degrade over time. And of course, create React app. Come on, it's going to take a while. Anyways, in the meantime, while we're waiting for that, oh, of course, there it is now. But one thing you can look at when you're just trying to check out the performance of an app is this profiler tab. And you can just start, well, you can reload the page and record how long it takes for things to load. So if I can stop double clicking things. Okay, so this page took all of 1.6 milliseconds of 10.8 milliseconds to load. There's probably not much we can do to make that any faster except get rid of the animation. But that's fine for now. So we all know about our beautiful new React app. Then we get into the software development lifecycle. So we start getting in sprints, and there's bugs and feature releases, and product is yelling at you, and support is yelling at you, and you're just trying to make things work. There's a little bit of structure for how you organize your files and folders. Maybe somebody took the time to organize things like context and set up different types using TypeScript. If you're lucky, sometimes you just get a jumble of stuff that people have hacked together over time just to get things through the door out to the customers. So in that case, you'll probably end up with something more like this. So this is just a little demo app I made up to show you a few points about like performance things. But basically what we have here is that we've just got this budget app. It's nothing fancy. Let me take you to where that is. So yeah, this is it. I wish this was accurate and I haven't spent any money this month, but that is completely wrong. So don't want to share my bad spending habits. So we'll just leave things as 0. But you see, there's just a few components here. If I had the thing showing, you would see that it changes like this particular component based on how I want to see stats. There's just a modal where you can add a new item. And of course, we have some kind of API call because we're saving a form. But this is just an example of how complexity gets layered on. And basically what happens is you end up adding a bunch of new routes, you have new components, you need to know how you're going to organize all those things, not just to keep your code performant, but something else that a lot of teams may not take into consideration is that debug time actually kind of counts towards performance, because when you have bugs or new features that need to get out, how long it takes you to work through those issues really makes a difference, like between promising users new features in a week or 2 months. So that's something else to keep in mind, is try to keep like a standard folder structure. So if you know that you have components that are going to be shared between multiple files, go ahead and put all of those in maybe their own directory. Or if you know you're going to need like helper functions, maybe go ahead and separate those out into different files that you import into the specific places you need. It's just one of those things that it helps you save yourself from technical debt later if you put a little bit of upfront organization in first. So when you get to the point where you're having performance issues, it's a lot easier to figure out where they're coming from instead of having to crawl through logs and get support feedback and just kind of poke at it until you can figure out where the problem parts are. So just some best practice things, like try to keep things separated, and also maybe not use CSS files. Personal preference, but it does help keep things a little bit cleaner. But as you can see, we have some posts that go through, we have some states that get set, there's different um, values we have to keep track of. There's just a lot going on, even though this app is incredibly small. So as time goes on, we'll end up with more endpoint requests, and we'll end up with more state values that need to be accounted for. And that is where a lot of our performance issues come. So for example, as this app grows, there might end up being 3 API calls in one component. Just because of how, backend things develop, sometimes it's easier for them to make a separate endpoint than to tack on a bunch of data to one you're already using. So that can slow you down depending on how you have your project basically architected. So there's different things that you can do from the beginning to make sure that everything kind of flows along the path as long as everybody follows it. But for the most part, there's just going to be stuff that happens. Like you're going to need to get these fixes out fast, and you're going to have 3 API calls you need to handle. So when you do get time to go back and make those performance updates, like usually that happens when you start getting all of those support calls, but when that does happen, then it's time to get into the good part. So maybe not the best part, but still pretty good part. It's where we get to test for places to improve. The first thing you want to do, especially when you're running locally, is go ahead and run that npm build or yarn build, whichever one you use. But basically, you want to see the exact bundle you'll be running in production. It'll show you how big your bundle is, how many chunks is separated into, things like that. It gives you a few just initial stats on what you can expect. And then the Perf React performance tool. So this is a really, really cool tool when you're trying to benchmark the performance of specific components. So you can basically time how long a render takes for one particular component and just get an entire performance report afterwards. And pretty much wherever you have that perf object set, you can get the report for that component on it. And it lists just a lot of stats like how long it took a component to run, things like if promises got hung up anywhere, or if there were network requests, just all of the perf stuff that you would look at when you're trying to figure out, hey, why is my app slow? And then, of course, everybody's favorite. I'm not sure if you guys saw like kind of the Twitter thing about what's happening with Lighthouse, but they're gonna start potentially recommending packages that supposedly help with performance. There are a lot of split views on that, but overall, Lighthouse is one of the best performance tools, especially for React, because it straight up gives you a report of things that you need to fix, and it scores stuff like, hey, you need to do better on mobile, or your general page speed is just too slow. So Lighthouse, remember. Then the profiler tool. So again, this is something I'm gonna show you, so I'm not just listing off random tools. We're actually gonna go through like a little demo of how you would use these on a production build. But I wanted to give you just a list of them beforehand, so in case you were taking notes or something, you would just have it to reference later. But there's the profiler tool, which is also another React specific dev tool. But what it does is time how long it takes for all of your components to render, but it shows it to you in the separate chunks, basically. I'll show you in just a few minutes. And of course, that beautiful, beautiful network tab. So when one of your components is hung up and it's just got that spinning wheel, this is probably a good place to check. There might be some kind of API request that you sent and it's just not getting a response from the server. And it might not even be a React issue. So this is one tab that I've noticed some front-end engineers kind of overlook when we're looking at performance, just because it's like, oh, that's for back-end stuff. Whatever, I got the right data back, or whatever, it hung up, so it must be something wrong with it. But this is a good way to really get in and see if there's improvements you can make on the back end to help your front end performance. And of course, the other Chrome dev tools are great. So I know that you all know about the Components tab where you can go through and look at props and change things and look at state. I'm not going to go too deep into that, but I will go ahead and do some Lighthouse Profiler Tool and Network tab, just demos. So we're back in our little example app. And the first thing I want to show you is Lighthouse. So hopefully you can see that it's just up here in the Chrome DevTools. It's just a tab now. I think I remember when it used to be a website. Maybe? I think that was a thing at some point. But now it's just in the tab, so that makes it super easy. And you can see which categories it's checking to give you a report for. So I'm going to go ahead and leave it set on mobile because we know how great mobile design is. So I think I've gotten this optimized. But if you notice, when Lighthouse starts, it automatically puts the site in mobile view. It takes it offline to see how fast it responds. And then it reloads everything and gives you this quick little performance report. So apparently, this little app sucks substantially. It is not a progressive web app to the point where there's just a question mark there, but it is super accessible, follows best practices, and has the highest SEO rating. You know, balances. Of course, we don't want this performance to stay this low, and progressive web apps are really great to make, but it truly depends on your application. So if you're loading a lot of data, like you're loading in even 50 to 100 rows of data, it might be worth thinking about making a PWA because all that involves is actually using that service worker that comes with Create React App. And Google has some really great tools, like their Workbox is incredible for getting caching to work. It takes a bit of upfront time to like work out the issues with caching, but once you have it solid and you aren't getting weird issues from users like data doesn't update when they think it should, or they're just seeing stale data all the time. Once you get past those issues, progressive web apps are incredible. They make things load so freakishly fast that it's a little bit exciting. So if you're having some performance issues, think about PWAs as well. But down here, they Lighthouse just gives you such a good breakdown on things that you can change. As you can see, there's just a bunch of tips for what I need to change to get this to be more performant. And gives us some screenshots on mobile. Yeah, just a bunch of tips. So now that you've seen Lighthouse, I want to show you the profiler tool. This one was really cool to me just because I didn't exactly know it existed, or I saw it sometimes, but I never figured out what reason I would use it for. But if you're trying to audit a React app and figure out places for improvement, this is also a good place to start. So I'm going to go ahead and click this reload and start profiling button. And all that does is reload the page and measures how long each component takes to load. So when I stop this, it gives you just a breakdown of how long it took each component to load, all the way down to the styled component divs. That's one of the best ways to get down to a granular level on which components you should probably look at first. It gives you like how long the total app component takes. So 1.3 seconds out of 93.3. Meh. But another good thing is that it uses colors. So this one in particular, our victory chart, it took a little while. It's a pretty hefty library, so that's to be expected. One of the things you have to consider when you're looking at these times is exactly which component you're looking at and everything that goes into that component. So some things that you have, they're just going to take a long time just because of the way that they work. And the workaround for that to show users is to do something like a spinner or give them a message saying that it's loading or it's in progress. You have to let them know something when your app isn't as performant as you want it to be. You have to give them some kind of feedback, or else they're just going to think that your app hung up on them and they might quit and never come back to your site again. I've seen it happen, so it's really not that uncommon. Make sure that you're going through this. Like the ranked view is probably my favorite when I'm trying to audit components in particular, just because it does rank everything in the amount of time it took to load. Then there's the interactions. We didn't do anything with the APIs, so we'll leave that alone. But you can trace API calls through this as well. It's just, if you haven't seen the profiler tool, it's super easy. All it does is calculate how long the page takes to load and break it down into the components. Then there was the network tab. This is actually one of my favorites, and I'm not 100. Actually, it became one of my favorite tabs when I finally figured out a bug of why a page wasn't loading. So if you ever run into an issue like that, make sure you're checking the network tab. But what this does, it just shows you pretty much when any request has been made. The most specific ones would be like getting all items definitely failed because I don't have this connected to my database. Again, I just don't want to share my bad spending habits. We go to Domino's and get pizza way more than we should. But that's what this tab is for. Like, if you get hung up on a request and you're not sure why it's taking too long to process, or maybe it's just rejecting the data you're sending it, so it's causing some re-renders to fail, this is the place that you want to come to check, because you'll be able to see, like, if you do have any parameters you need to send to the backend, you'll see the exact values that were sent in the request. You'll get whatever response you get from the server, whether it's a good or a bad status, and it breaks down how long these requests take too. So if you look over here, you'll notice that all of this stuff moved really fast. Nothing's too crazy. But let me see if I go to goals. We have another network request that just stays as pending. So this is something that happens when, like, a backend might return a 503 or a 404, or maybe your promise is just stuck. It's just a place for you to go start looking to see, hey, maybe if I fix this thing, it'll speed things up and it'll get the user through whatever process they're trying to do just a little bit faster. Up here, one thing I want you to notice, because we're about to talk about it, is this chunk. You see how big it is and how long it takes? Like, this is a whole megabyte, and it takes almost, what, 500 milliseconds? That's really long time for a chunk to load. But that is because of the size. So for the most part, we like to keep chunk sizes small if possible. Anything that's in the kilobyte region is probably okay. But once you start getting into megabytes, that's where you'll also see some performance issues. But now that we know how to test everything, get through that, we'll talk about how you can keep your app performant. So one of the first things you can do, again, if you're loading in a lot of data from an API request, you probably want to at least attempt to virtualize your lists. And this is really similar to lazy loading. So it'll only give you the data you need when you need it. And that saves a lot of rendering time of just waiting for all of the response data to come in from the back end. So virtualized long lists, there's of course the React apps, the React docs are great. I'm trying not to just fall over and praise them for being the best JavaScript framework, but they kind of are. So talking about lazy loading, that's something else that we're going to demo briefly, is just a way of making sure that your components only get rendered when they've been imported into whatever view you're trying to show. And of course, caching data is something that I mentioned. If you can take the time to make your cache work, your service worker work correctly, it really can be worth it, especially when you're dealing with a lot of data. You don't know if people have bad connections, so that'll help with your Lighthouse score, and it'll really make a difference for your users when they aren't waiting like 30 seconds for all of their banking info to load. This one I'm pretty sure is a pretty standard one at this point, but make sure you minimize everything. JS files, minimize it. Pictures, minimize them. HTML, whatever, minimize it. Just minimize everything. It'll keep your bundle size low, smaller, and it'll help when it's time to break things up into chunks. This is another great one that sometimes it surprises me how this gets overlooked on the front end, but handling errors will also make your apps more performant, because instead of just crashing, they'll show the user something where they can possibly take an action, or at least they're not left just in the dark trying to figure out what they did wrong or if the app is just broken. And checking your bundles, chunking your bundles, this is something else that we're going to talk about. Like, I'm going to show you exactly what I mean there. And that might be a little bit later, but for now, let's talk about lazy loading. So I got a quick little example here. Well, not here. Here, where I just wanted to do this as an example of how you would actually lazy load a component. You already know how you import components from different files, no big deal. Lazy loading components, it's the same thing. It's also no big deal. The only difference is that you need to have suspense along with lazy, just in case it takes a while for the component to come back. Like, what happens is that this page still gets rendered, but if this component, this goals component, hasn't been completely loaded in, then it'll cause the app to crash. So what we want to do is kind of like what I mentioned earlier when I was talking about showing the users like messages and giving them reasons to stick around for your slow app. But this is one of those ways you can give them feedback. When you lazy load components, you have this suspense wrapper where if that component doesn't load, it just simply puts in a placeholder so that the rest of the app doesn't crash and it keeps going. That's how you lazy load components. And honestly, I haven't personally seen a reason to not do all components like this. I'm sure there is, but for the most part, I haven't really seen a reason for us to not lazy load everything. but maybe somebody can have a talk with me on Twitter. You can at me at Flipped Coding, by the way. But yeah, so that is how you lazy load a component. Now, not much here. So this is the meat and bread of performance. How do you clean up an existing app? What that means is that you have this app that has been in production for months to years, and it's just slow in certain areas. So you have the task to go in and clean it up and make it fast again. One of the first things you can do is try code splitting. So this is usually used when you're using something like Webpack, but for the most part, all this means is that you're lazy loading all of your components, but you're also breaking the chunks of your bundle up. So when you do something like this lazy load, you can basically make it so that each of your React files, it becomes their own chunk. And that makes your bundle size a lot smaller so that those files only get called when they need to be. That's one of the big ways that you can reduce your bundle size and speed up your app significantly. Then something else is tree shaking. So you've probably heard that term quite a bit, but the gist of it is you're getting rid of all of the dead code in the application. That means if you have unused packages, you go ahead and delete them from everywhere in your app. Or if you have unused variables, functions, pretty much anything, if it's not being used, get rid of it because that's going to slow your app down more. It's just taking up unnecessary resources. Oh, yes, hooks. It's finally time for React hooks. So, if you aren't familiar with the use context hook, I know there's a few of them that sometimes they just don't get touched very often in projects, but the use context hook is incredible when you have that problem where you're passing down props like multiple component layers. So if you know you have some data that needs to be used across the entire app, like different files will be referencing it, this might be a good case to use the use context hook. So another hook that is it's also a little bit rare, but when you see it, it's really powerful. So the use memo hook works by basically not requesting data unless it sees specific parameters have changed. So let's say you have a form and maybe you only post updates when a specific field has been changed. So unless that field has been changed, that data won't get updated. That's how the use memo hook works. And then this one might be my favorite thing, is refactoring components. Like you get to go in and throw away all of the code you don't like and write it how you want it to be written. So that means you can change the file structure to be more PR friendly. You can switch from class components to function components. You can add hooks. You can add libraries. You can do whatever you want that's going to clean up this app and make it work better for users. So that's pretty much all of the tips that I have for cleaning up an existing app. So one of the things that I'll kind of try to show you is maybe some tree shaking. It's not the best example, but if you do have comments in your code, that also helps clean up the bundle size and get things to run faster. But with that being said, we can just go ahead and wrap up. The first thing is that don't take performance issues to heart. They just happen over time. Like you'll be working on an app for months and you'll start to notice that some of the changes you personally have made are starting to slow things down. Sometimes there's really not much you can do about that until you get the time to really focus on performance. And then the best part, there's so many free tools. Like the ones I showed you are pretty much just in the dev tools, but there's also websites where you can go on and put your URL in and it'll give you some stats back, like just page speed and which pages are slower than others, things like that. So you aren't limited to just using React tools. You can branch out and do other stuff. And honestly, most performance issues aren't terribly hard to solve. It's just a matter of finding where to solve it and making a plan for how to solve it. If it means that the backend APIs need some updates, well, they just need to be updated. If it means it's time to refactor, it's just time to refactor. Performance issues really just need some time. And then something else. You don't want to be banging your head against the wall, trying to figure out why nothing's running faster, even though your bundle's smaller, you don't have any dead code, and your lighthouse is just out of this world. But there might be a problem with your server. Maybe you don't have enough RAM, maybe there's not enough memory, maybe you're running the wrong OS. Who knows? Those issues do come up, but make sure that your resources scale along with all of these performance updates. And again, keep an eye out for those unnecessary packages. So there are sometimes we try to import libraries to make really, really simple stuff easy when it would be easier to just write a little function for it. Like that, it happens. Not every project needs Lodash. I'll just say that. And then the most important thing to help performance continue throughout a project, make sure that you're telling people why you're writing code a specific way, even if that's just with comments sprinkled throughout the code or a document drawn up somewhere that highlights the main features of it. Whatever it is you decide to do, make sure that somebody else can understand why you're doing it and kind of what the reasoning was. So when you have all of these things together, then you get that beautiful zen of a super performant React app that no users have problems with and there are no bugs. So if you have like questions specifically or you want these slides, just check me out on Twitter at Flipped Coding. That's where I hang out occasionally. So I'm open to questions. I am done.
So here I am again. Milecia, thank you for your presentation. That was really informative. And I'm bringing Jen back and Carrie for our Q&A session. Hi, guys.
Hey.
First of all, I would like to thank you again for your great presentation. All of your presentations were really good. Not good, but great, with all those memes, with all those jokes, Gent. Like,
I'm like, I wonder if you guys caught some of my puns, because like,
Yeah.
Key takeaways.
You had a really good set of memes. I love the memes in your presentation.
Right.
It's good. I am a sucker for animated GIFs and memes. Just like any talk that you can add, if the more of that, the better.
Well, I know like security and security teams can talk down to devs, so I wanted to make something a little bit more relaxed and more knowledge share.
Yeah.
I thought memes would like be like, I'm not telling you, I'm more like advising you.
Mm-hmm. Yeah,
Well,
that's good.
and I'm your friend, not your nemesis.
I'm not telling you how bad your passwords are. I'm telling you how to improve them.
But anyway, you know how to drag the attention properly
Yeah.
to presentation. So
Sweet.
let's start from the beginning. We have some question on Pine platform. The first one is to Carrie. So here it is. What if I wanted to go from software to hardware? What would I do?
Well, software and hardware are way different things, and I know I did a big pivot by going to like web to security, but there was something in between that connected, and that was web security. So for you, I would say you could either find something in between to pivot, or just dive right in, like go to hardware stores and buy things and play with it, or just figure things out. Because there's a lot of places that do donations or just drop out like old machinery. So those are my suggestions.
Great. The next question would be to you, Gent.
All right.
But if ML runs on browser, won't it consume client CPU memory? And won't it create issues if client has subpar system?
So one of the cool things about TensorFlow.js is that it actually accesses your GPU as a backend through WebGL. What? So if you have a GPU, boom, it's hitting the GPU. Now, let's say you don't have a GPU. They actually also support in TensorFlow.js WebAssembly. So you can actually get pretty close to GPU speeds by switching the backend to WebAssembly. And then, like if your users are going to be on mobile devices or something that's a little bit more optimized for WebAssembly, you can actually get a pretty awesome project. Now, just like everything, when you're on the cutting edge, you're going to bleed. So one of the things that might happen is I'll say that, yeah, I have started developing while my laptop was at 100% battery. And then an hour later, through some kind of mismemory management, my laptop's screaming at me to plug it in. So I will say yes, you can feel the pain of these things if you're using too much, and I can't help myself. I have like fading gradients in the background and glowing text. So my GPU absolutely saps my battery. Be a little bit careful. But I think it hurts the developers more than it hurts the people, because I've seen some pretty amazing performance with WebAssembly. And I think as it starts to really approach the GPU stuff, it'll be really good, especially for infants.
Thank you. And
You got it.
Next question is also for you.
Yeah.
It sounds like, yeah, you got a lot of them. Yeah.
I've been writing myself questions is what's happened here. I just, during other
You can actually. You can,
what, you should do that.
because you have more time to tell about your topic. If you had not like if you had a small slot for the information, you can use Q&A session just to continue your speech.
Oh, I did not know that. I was afraid I was going to go over and like interrupt everyone else's time. So I left things out.
It's okay if you really have some information remained, and if you want to share it, you can do it like just right now. Like you're really allowed to do it, and I think that our viewers would be extremely glad to hear like more of important and interesting information. Like they are here for it.
Well, one thing I can mention was I didn't talk about the keys, like the symmetry, like having the symmetry and asymmetrically. I had it on my slides, but in the interest of time, I kind of like glossed it over. So symmetry, they have two keys, a private and public key, and you're most used to that like doing SSH like keys for GitHub. So, and I know GitHub is like changing their they're getting rid of passwords, I heard. So it's gonna be like you need to learn how to use that and learn to use it effectively. Symmetric is you have one key and they share that key, and that's the main difference between those. Things I left out, like out of the whole thing where I felt like it would have been too much for a 101 was like JSON web tokens, because those are kind of like tricky to like configure correctly.
Yeah.
At times, session hijacking, and then cookies management, and also cross forgery. If I had to say anything about that, it was like have a token and use it. So those are like my other key things that I kind of like swept away at the time. But yeah.
I love it.
Thank you. And the next question is, how is TensorFlow compared to machine learning libraries in Python? This is for you, Gant.
Oh, yeah. So, by the way, I know Milecia, you have some experience in this stuff. So feel free to weigh in, because we were on a podcast together recently. It was a lot of fun. So, but I'll start that off with, Python is the data science language. And it's been like papers are published in it. Everything's kind of there. So I'll say that like it's performant wise and its capabilities and all the information there, you gotta still know Python. It's amazing. However, I will say that JavaScript being birthed recently into TensorFlow JS, having GPU access, going out in places Python can't even follow, if seeing it catch up and start to pass up. For instance, Node is faster than Python because it's like C++, like is the backend for it. So actually, if you trained in Node, you might be able to actually train faster than you could in Python. I actually think you might be able to. And additionally, I'll say one other piece of that is the libraries are coming. So cool libraries like Pandas didn't exist over in JavaScript world, but then they made Danfo.js and they're doing other cool things like that. So if you have your choice, it depends on like if you're doing front end or like back end stuff. I would say whether you want to use Python or TensorFlow JS, TensorFlow or TensorFlow.js or Python or PyTorch or whatever it is that you want to prefer to use. So yeah, I would say like depends on what your end product looks like. Make the smart decision, but they're pretty fast.
I'll kind of chime in on that one because, sorry, Gant, I don't like TensorFlow JS.
Okay, that's you know what? What's your preference? Do you like Brain.js?
This is another just JavaScript machine learning library, and if you can work with arrays of objects, you can pretty much do machine learning.
With Brain?
Yep.
Brain is amazing. It's GPU accelerated. It's not backed by a major company, so that's good or bad, depends. It actually has some serious optimization. It's a care taken by Robert Plummer, but it hits a wall because it currently doesn't support convolutional neural networks. So wouldn't have been something I could have used for this. But I think Brain, yeah, and it's got free tutorials left and right. The truth is this: there's a team of people, and IBM and Intel and a bunch of other and Alibaba who need some of the major features. So there's large corporate sponsorship behind TensorFlow JS. But if you're getting started, I agree. I think Brain is amazing.
It is.
Yeah.
I love that library.
Wow. I'm just like learning so much because like I used to be in the Anaconda world, like when I first started out. So like the big thing for me was like when D3.js came out for data visualization, and I was like, what? I don't have to do like some shifty stuff anymore. So
yeah, it's amazing. Yeah, and the Python stuff so data scientist centric. It's kind of nice in some ways, and then you create a product and you get frustrated because there's no easy path forward from that. I like to call these as two separate islands, and we're all building bridges, figuring out how to do it.
So the third question is how we contribute to the open source.
For which project?
This is for you also.
Okay. Yeah, I'll give you the link
We're going
right
to
now.
talk a lot this evening.
Yeah, I'm happy to. I'm sorry. The link is my GitHub/enjoy the show. It's before I bought the domain. So let me put that in the public chat or share it with you. Actually, I'll put it on Twitter. Look, marketing, right? High five. High five. I'm a developer who learned how to market. Go find it on Twitter. I'm going to post it right now. Yeah, follow me.
Think about it.
Yeah.
And the first question is also to you. So API are running in server in any language or framework like TensorFlow and Python, while data is feeding continuously from DOM server.
Okay.
This is a long question.
I wish I could read it. Yeah.
Repeat it, or you can read it by yourself at this question section in YouTube.
Oh, I need to.
Yep.
I have so many windows open. I didn't open YouTube. Look at that. So it's
so API are running in server in any language or framework like TensorFlow and Python, while data is feeding continuously from DOM server.
Okay. And just to go back to a high-level overview, maybe this helps out. The TensorFlow was running in the browser, and the client-server architecture was all on client. As a matter of fact, none of the model was on the server. The server actually was ignorant of anything from AI. It was receiving strings, array strings, and it was processing and handling that. Your machine was processing the TensorFlow JS, was doing all the process and just shipping strings, which I know Carrie was having a heart attack because that seems like I'm getting all kinds of data and it's not secure. But I promise you, it was very secure. I didn't get anybody's faces or any of their facial dimensions or recognition stuff. And you can actually watch through some of the tools that we were talking about before. You can watch what's going over the network. It's doing all the inference locally, and it's going to the server. And the server I wrote also in JavaScript. In fact, I did all of that entire project in JavaScript for us.
Mm-hmm. So I'm looking for another question.
I see one for Milecia actually over here.
Mm-hmm.
If you click on comments, Milecia, and look in the middle, it says, should we start performance testing of React app after each page build or at the end of the entire development, and why?
Where is that? Oh, I see it.
Yeah. There's 3 different places where we can have information. I kind of enjoying this. This is fun.
Find this.
I would say it would probably it would probably be better to wait until the end of the entire development just because when you benchmark specific components, it doesn't give you an accurate view of how they all work together. So that's, I don't know, that's kind of my reasoning behind it, but it definitely doesn't hurt to check performance after each build.
So the next question is, can you specify any recommendation for cache management in React? Maybe
Ooh,
I pronounce it not correctly. Cache or cache?
Cache?
Cache.
Cache.
yeah.
Cache.
Wait, I'm here. I'm ready for this question.
So,
Not bad.
but as far as cache management, honestly, if you use Google's Workbox, I think that's probably about as good as it gets. A lot of it is just trial and error, making sure that you're caching the right values, that things get refreshed, that you're using the right like methods. So for caching, it's a tricky thing. It really is just trial and error with those workbox methods.
And um, the fifth question is, where can I find that source code if I want to refer it?
I'll have that on my GitHub, which I will post on Twitter. So if you want to find, just
You're
you
following
know,
that.
go check me out on Flipped
Yeah.
Coding at Twitter. On Twitter at Flipped Coding.
Okay. And Milecia, the next question is to you. What would be a good app project to start with, and what are the best tools to test it and deploy it? A
So
good question.
I guess that's like just whatever project in general. So maybe a good app to start with that's not just a to-do list would be something like, I don't know, make a scrapbook. People like scrapbooks. It's something you can share with your family and show them how smart you are. But something that you could test it with, this is one that would really benefit from some performance because of all the images you'll be using, but probably just the ones that I mentioned earlier. Like those cover just about everything with React. And as far as deploying it, ooh, gotta do another plug. You should use Conducto for your CI/CD pipeline, but I don't know. I like Netlify or Heroku for just little quick apps. They're super fast to get going with.
And Carrie, we have a question for you. What would be an easy approach to web security for a small business website? What can we do to start implementing security measures in our small projects?
Well, it depends on security needs of that small company. Like, it depends. Are they doing a lot of processing for like money transactions that are not through a vendor? Do they need to get something like OAuth? Like a lot of the things they can do is get it offloaded to someone else while they're still building. And so I know for most startups, they start out small and they have development teams, but they usually don't have a security person or a person that's focused on security. So if they can bring somebody from the outside as a vendor or just a person to consult with, that would I think that would help most small startups.
Mm-hmm. And what is the learning curve for? Yeah, this is for you, Gent. What is the learning curve for TensorFlow is compared to Brain.js? This is for both Gent, this is for both Gent and Milecia. Are there ethical concerns with both libraries as well?
Ooh, I like to just jump in on that one.
You got it.
Ethical concerns, maybe it's a slight jab at Google, but I mean, they did take the don't be evil thing out, so there's that. But no, it's actually fine. I don't think there's really any ethical concerns with either. Do you, Gant?
I'll say that what I think is really important is that this needs, like, machine learning needs to be given to developers. It needs to be democratized. And I was pretty frustrated that only a few companies had this stuff. I'm pretty proud of what Google's been doing in training people, building special interest groups, giving things away, and stuff like that. So I'm kind of happy that at least these groups, their Google Brain team, has been phenomenal. They're hiring developer advocates. I feel like they're listening to people and they care about the ethical concerns. Now that's how I feel, and there are definitely some aspects and some. Google's so big, right? There's some sides of it where you might have some issue, but the people I've met who are running TensorFlow and the TensorFlow JS team are extremely, extremely nice, and they're doing their best they can to ramp you up. I'd say that don't pick one at all. Learn Brain. There's a free course by Robert Plummer that he did, and I could send that link to you and just message me. He taught an entire course on that. Learn that one, and then go learn TensorFlow, and then find out which one fits your project, makes you happy. So I'd say I would agree. I would throw away the ethical concerns on TensorFlow JS for now as the group that's there. Now, AI always has ethical concerns, but for picking one, I say learn them both. You'll probably get a bunch out of one course or find one flavor or another, and you'll be so happy because you'll be in all the cool stuff.
And the next question is, hi, I'm getting into Microsoft Azure.
Hi.
Are you familiar with Docker? Because I think I've seen Milecia with the Docker in Visual Studio.
Yeah, I run Docker. It just makes it really easy when I'm switching computers, because sometimes I work on Windows, sometimes I'm on Mac, Linux, and if you've tried to set up the same project on those different OSs, it's just a pain. Like, there's no good comments I can say about that. But with Docker, you don't have to worry about all of that. You just get your image, you build a container, and you have this magic application. So, I was definitely using Docker.
The way Docker was born, by the way, said a developer said, "Hey, it works on my machine," and then they said, "Okay, we'll just ship your machine," and that's what happened.
Okay, I thought that was gonna go way, way worse than that. And you find out like his machine is the only one, and then it breaks, and then you're like, I wish we had his machine again.
Yeah, that would be the 2020 story. I probably messed it.
That sounds right for this year.
Yeah.
And the last question is, what are the tricky part about JSON web tokens?
That is a good one.
Oh, like, I know you guys can chime in on this one because like everybody has their thing, but it's like there's one point where authentication was a thing and you would set it to no types, and then it would reset itself somehow and it would let things through. And I was like, when I saw that, I was just like, no. Like, I set it for none and I got something and it's not what I wanted, and it goes against like whitelisting and blacklisting. So at one point, web tokens had that. I don't know what they have recently, but you guys can chime in because you're using web more than I am right now. So what have you guys seen that's the most difficult part of like nailing down web tokens?
I can say that I went ahead and built this. I got so done with Amplify uses JWT for Cognito, so I did a login app, and as everything was all set, like yeah, everything's set. And then I had another person come in to help out, and what was really funny is they didn't understand how web tokens worked. So what they wound up doing is getting me access for 1 hour at a time, and then it would get the person like logged out. And I had to like go back and explain to them. Like it kind of gives you a couple of foot guns, along with it, because you have to really get into it. You have to think security, and I think pretty much your whole talk is like sometimes developers just don't, in a few ways. You have to learn all these concepts before it actually clicks. And I think that one of the things that happens with the JWT is that it's cool when Amplify wraps all the services, but as soon as you have to do one thing unique or you have to get in there, you have to like sit people down and make sure that they didn't just make a security vulnerability or some kind of user problem with JWT, which is what happened.
They're hard to configure.
Yeah.
Yeah, I think that's my complaint too. Is like sometimes there's just so much information in them that we don't actually need on the front end. And yeah, I've seen that lead to some weird session stuff. It's like, why is this JWT not? Why is this just not working?
Yeah.
Guys, you're so great. And I'm reading all these comments, all these questions. You got so many compliments. Everyone, they are writing so many things to you. And for example, Shobit Ratan wrote things, Gant and Milecia. That was very informative. I recently graduated from college with a degree in MS in data analytics and software engineering immersive program in Flatiron. I like both. And I remember that when you, Gant, was presenting your speech, your presentation, I remember one great comment that your presentation was a gem of a conference.
I really
seriously.
It means so much to connect with y'all, and I want to say, thank you for hosting this conference. By the way, I know it's just you, Anna. You're the only person who ran this whole thing. You're getting all the credit. But during a pandemic, I don't get to see people. Wait, it was you and a Red Bull? Okay, good.
This is helping me to help this conference, because actually this is 8:40 a.m.
Yeah.
If I'm pronouncing not so well some words, please sorry me. Understand me.
I mean, it's totally. This is great. I really miss this. I love that I made some new friends today. I've got some new people who are going to be chatting with me on Twitter, and I love that I've run into Milecia before, and we're going to keep talking to one another. And I know one of the talks that you're going to be having soon. I want to go see all this stuff, and then I don't leave my house anymore. There's a pandemic out there, so I'm really happy to spend this time and get this. I get to see people again for the first time.
True. It has been so weird not going to conferences this year.
I know.
I miss people.
I'm introverted. I don't come off it. Yeah.
Oh, guys, we have two last questions. Shobit Ratan is asking you, I implemented GWT in backend for Rails and Django and transferred the token into local storage after authentication. Yeah, I did it. Is it a good approach?
I'm like, it depends. I'm like, where is local storage for you? Is it? I'm trying to figure out right now in my mind if it's local storage in your computer or their computer, because it also depends on the trail. So I'm looking, how I'm thinking of it is similar to a pen tester. So you have the browser, you're off, you have your key, your token, and it moved off of the session. Now it's in your local storage. Does it get removed from your local storage? Does it just stay there forever? Like, I have so many follow-up questions to that to like actually answer this like successfully, and I do not want to lead you down a wrong path. So I would rather you like contact me after this and like where is go like what is happening, because like I do not want to steer you wrong.
And the next question is question for everyone. If you look back to your career, what advice would you give to junior devs starting in 2020?
I think my biggest piece of advice would be try not to get swamped with learning everything at the same time. Like, it's okay if you just do back end in Node to get started, or if you want to do front end, of course, React. But try not to get into that mindset where you have to learn every tool out there, because you literally cannot learn all of them. They make new ones every day.
Yeah, I wanna +1 on that and say it in an interesting way that I wish I had heard as younger. Is that the technology we all know today ages terribly. All my tech books age terribly. Being the best at one thing in tech is both the blessing and a curse. It ages terribly. What you should learn, two things. One, concepts, because concepts stay, concepts persist. And two, people. Work on your communication with people, work on where people need extra help, because people don't change. I wish that we kind of worked on our communication with everything, keep the humanity in it, because what you learned 20 years ago about people will help you communicate and build better products, forever. So concepts and people are the real goal. Being excellent at knowing a book backward and forward, not having to Google something is honestly useless.
And so to piggyback on that, everyone uses Google.
Yeah.
That's why it's there. Even seniors use Google. Everyone uses Google. So that's a thing. For me, I would say community has been big. So like we're so far apart now, like we have to go out of our way to network with people now. Like this was weird for me because like I'm used to seeing and hearing people and like feeding off a crowd when I give a talk. So, but getting out of your comfort zone to do something, for me, I got out of my comfort zone and got into security because I got tired of having like security incidences happen, and like I don't know when it's happening. So it's interrupting my personal life more than just being on pager duty. And also it's something just to learn. And sometimes you have to be open that even if you start in one place, you might end up in another, and be open to that journey if it happens to you.
Yeah.
And the very last question is to Gant and Milecia. Gant, what is your biggest project for JavaScript?
Biggest, I guess anything that has node modules installed. That would be huge.
Oh, that that brings me
Oh
back.
gosh, that was awful, but it was so good.
It's so accurate. That's a real hard question to kind of get to. Biggest in a lot of ways could mean so many different things. I will. Yeah, I'll say that.
Okay, the greatest that
The
you are proud
greatest.
of. Yeah,
Okay, that's
that
it.
you are proud of.
All right, I got it. I made a website that can tell if someone is or is not Nicolas Cage. It is very
Yes.
important. It's
Mhm.
obviously very useful and probably the biggest and best thing ever because you need to know whether or not Nicolas Cage is in a photo or not. And so I made a mobile app for it. I made a declaration of independencethief.com. And then when I submitted the app to the App Store, they actually kept rejecting it, saying this isn't useful. And then I told them, I actually sent them a picture of the Apple logo and I said that they're affiliated with the Illuminati. And then they let the app into the App Store. So I don't know why that worked, but if you go to nickornot.com, you have probably the most, my greatest, my raison d'etre, if you will, is set there. So yeah, go to nickornot.com. Very useful.
He
So,
is supposed to be the new Tiger King.
Oh, that's right. What is Nick doing with his life?
I'm like, did you guys see my Tiger Team joke I had?
Oh yeah.
Yes.
Hey,
Yeah, I tried. I tried to be relevant with the times.
It worked.
guys, you are awesome, and it's so nice to see you like in this good mood with such great vibes. And I think that you will get like good well with each other. And please don't forget to post all those information that was asked previously on your Twitter, as you have already mentioned. So thank you very much for this like time. That was like I've got so much fun, and I'm sure that our viewers got lots of important and interesting information from you, and you can be sure by reading all these compliments. So, guys,
awesome.
thank you very much.
Thank you so much for having us.
Yeah,
Good seeing
thank
you.
Bye.
Bye.
Okay. And before the next speaker starts his topic, we will make a break for 10 minutes, just for you to make some sandwiches, make some cup of coffee, just have a rest and come back to us. See you in 10 minutes. So here I am again, and I'm more than happy to announce you a Fireside chat. So join author and OSS technologist David Mark Clements and VP of Engineering Luca Maraschi for a Fireside chat as they draw on their combined 30 years of programming and industry experience to discuss topics ranging from high-speed CSSR with React to solving organization complexity with distributed system of React components. So, welcoming you, David and Luca.
Hey Anna,
Hi,
hey
guys.
Dave.
Hey.
How's your mood? How are you?
Oh, my mood's okay. I'm just awake. I'm in Amsterdam, so I'm usually grumpy in the mornings, but I'm making a special effort.
Good morning. We also have morning. We have 9 a.m. in Ukraine.
Good
Oh,
morning
wow.
to you.
Yeah.
So Dave, you're
And,
gonna be
and Luca,
my,
what time is it for you?
David,
Sorry?
you're gonna be my usual good night story, right? So here is 11 p.m. I just gave Nicholas to Julia for the sleep, and then it's your time now to sing me the song, right?
Luca and I often have a call at his time at night. That's what he's getting at.
Yeah, I hope you got a good rest before this fireside chat. So, so if you're ready to start your speech and to share a screen to talk, please tell us, and I will disappear and give you more space on the screen.
You
Yeah,
can
I
always
don't think
stay
we're going to be
there.
doing any screen sharing. It's more of just a chat.
Sorry?
Yeah.
I don't think we're going to be doing any screen sharing. It's more just a chat.
Okay. So, see you soon.
See you soon. Hey Dave, I love your mug, by the way.
Yeah.
I guess you got it in London, right?
Yeah, I picked it up in London.
Yeah, I could guess it. Hey Dave, so I think it's kind of nice if we start our usual kind of chat. Maybe we know each other for some time, and maybe we can just give a quick intro to all the people that they are so patient to listen to our 40 minutes monologue. So maybe do you want to start telling something about yourself, just for the people to understand who we are?
Yeah. So I guess I'm. Well, I got into coding quite young age, and went with what was most accessible to me at the time, which was the browser. And so really started writing JavaScript, HTML, and CSS in the mid 90s, 96, 97. Yeah, I mean, focused on that for a long time, and then did some PHP stuff. And then when Node was in its early days, I thought this is going to be amazing, and ended up writing a book about it called Node Cookbook. And then got involved in doing consulting on Node and consulting on just general front end stuff, which turned into doing some React consulting as well. And that's where we met on the Node and React consulting stuff.
Yeah, I mean my story is a little bit different. I started with when I was young, right? And I started actually writing games, and then I moved into programming microcontrollers, and then selling a couple of companies in the meantime, building a game engine. But I think I kind of always touched the front end side when I got into mobile development, and then I started play a little bit heavily and hard with iOS, Android, BlackBerry at the time, and try to kind of figure it out if there was a better way to write the same application on multi-platform. And so everyone went through building your own JavaScript interpreter for mobile. And most recently kind of approaching large scale well, when we met, we started already the journey, right? Helping Fortune 500 and Fortune 100 companies to scale their digital transformation. And then, until last July, I was leading technology in Talos, and now most recently, I took a different kind of challenge, and that's more on the scaling up, a startup to the next phase. And I think in this journey, in terms of like telling a little bit who we are, it's kind of interesting to kind of share some of our war stories on when we had a lot of fun traveling the world, and maybe a little bit more recently, our last touch base when we were before we kind of forked our, just to use a kind of techie term, we forked our way. And
yeah, well, I think it's interesting to when you've been stepping into different companies and seeing how they're doing things. It's really interesting to see how trends can emerge. And what we noticed over the years, and it became a stronger and stronger thing, was the need for federation in large enterprise organizations as it relates to the front end, because to a certain extent, decentralization of ownership had already occurred in terms of microservices and things like that. But on the front end, and still, you still see this. You have a lot of teams all contributing to the same repo or repos that go into a CI pipeline and then a build occurs. So when you have 8 teams with 6-7 people in each or something like that, all building things for one site that's say built with React, things can get messy, things can break, and CI doesn't necessarily catch everything. You're only as strong as your weakest link in those situations. In one organization, which was a huge operation, we're talking billions, but they had a developer that modified array prototype and pushed that to live, and then it caused problems for loads of teams collectively. So it was and still is really, really easy to stand on each other's toes in the front end. And we've been looking at ways to address that for years now. So I think that's an interesting problem in the industry. It still isn't fully solved. It's more solved now than it used to be. But it all comes down to what we identified, right, as managing logistical complexity, because these are actually people problems and organizational problems and communication problems. But as per Conway's law, you replicate the way that an organization communicates is replicated in the technology that they produce and how they produce it. So when you have, as you tend to in large organizations, a dispersed ownership of many different things that collectively make one thing, and in some ways those things can be competitive, and also not necessarily not always friendly to each other, then that kind of thing then can manifest itself in the creation and deployment of code. Go ahead. That's
Dave, I think could be interesting to just go a little bit deeper, because you and I have been tons of conversations, right? And I think it all came from when we were all very early in the React. We are at the React Summit, so definitely it's worth to mention that we were pioneering, kind of researching on how we could basically take React to the next level, right? And we both work in the past for Nearform, who made large investments in try to optimize, technology for enterprise and for those kind of scaling problems. But I think it's kind of interesting to say where our consideration of scaling came from, right? So when the infamous server-side rendering in React that took us busy traveling the world, right? I mean, we cannot mention the customers, but I think we can high level say one of the largest media company in the world with a kind of very nice building in New York. Same thing with large e-commerce in Chicago that I still remember the travel going down there. But, we kind of have all of some history there. And, we found out that basically Node as a growing technology was kind of somehow stopped, or there was some sort of natural break as soon as server-side rendering was put into place. And, and the single-threaded nature of Node was put into discussion.
Yeah, well, I mean, the thing is, I think when you're talking about React, depending on who you are, you kind of think about it in a different way. If you're primarily a front-end dev, you really think about it in the context of the front end. But as we were and still do, we're focused on some part of the back end, and particularly Node, and using Node as a mediator as the front end of the back end, and in that sense of
back end for the front end, you meant, right? Yeah.
When you're looking at it like that, then there's a slightly bigger picture there, because inevitably the question rises, should we render on the server? So pre-React, you would use something like Mustache or something like that to create HTML templates, and then
handlebar, SAS.
Yeah,
we all know them, right?
Using like jQuery or Backbone or even Angular, and that works fairly well. But when it comes to React, the way that the rendering is done is different. When you're rendering a template, you just concatenate strings together, essentially. With React, you're creating a large tree, and then you're traversing that tree and serializing it into HTML on every single request. And when you do that, the size of your React application really comes into play, and you can start doing something called blocking the event loop. So it's a highly computational task. It's resource intensive, and it takes time to do in a way that stops I/O from happening, because the event loop is busy doing that.
Yeah.
If you have a lot of requests coming in, that can create real issues in terms of slowdown. You can have timeouts and different things, and it's really important to remember, especially if you're coming from a front-end perspective, that the browser has a one-to-one ratio with the user. So that event loop in the browser, the JavaScript event loop in the browser is one-to-one with the user. But when you're using it in Node, it's potentially thousands to one service. So it's a shared resource. The event loop in Node is a shared resource. So server-side rendering can be something that you think, oh, it won't be a big deal, we'll just turn it on, or we'll just set it up and it'll take half a day.
Yeah.
And then suddenly you realize, oh, we actually have problems here. It's the first thing you really need to think of. You need to think of this problem like laterally, and the first thing you need to answer is, should we even be doing server-side rendering? A lot of what we've seen, I think you've seen this as well, is most people think that they should do server-side rendering. And in some cases, they think they should do it as a performance optimization, because like tools like Lighthouse and different things, will say, if you send HTML to the browser, then you're going to see something come on the screen, and then the library, the actual JavaScript framework or library, whatever you're using, is then going to kick in afterwards, and and then connect with the DOM in that way. So it should theoretically be faster, but if you've got a bottleneck on the server side, it's not going to be faster.
No, exactly. And I mean, I this year was my year about like serverless side rendering, right? The concept of like trying to kind of go away from server side rendering only when it's really necessary. I do deeply believe, and I saw, and I think you too, right, that most of the common use cases, server side rendering is just an excuse, and I think it comes a little bit from the history, right, of Node and React and so on, right? So it came all from Express having that kind of render functionality that gave some sort of sense of like one size fits all to everyone, which it was, right? And that, I think, what kind of, between kind of quotes, destroyed the whole right philosophy on how to build large scale distributed applications, right? And especially in 2020, I'm a strong believer, and especially if we are right now, imagine that we have a lot of front-end people listening to our chat, right? And we are mostly focused on large scale, massive scale problem, right? And so we look on micro benchmarking and micro optimization, but if you look on the scale, right, I do think that actually that separation of concerns, that demarcation line between front-end rendering and just pre-rendering, it's way more powerful than say, oh, let's server-side rendering the hell out of it. And you have libraries like Next, for example, that try to have some sort of opinionated way and some sort of like a heuristic way of handling that thing, but I don't think it's heuristic enough, right? It's just like always gonna hit the bar of performances.
I mean, so my sort of general advice on it is, if you feel that you need to be sending HTML, we just brought it up, pre-rendering, snapshot rendering, whatever, they have different names for it, but being able to render sort of offline in some way, and then pushing that to the edge, if you can do it from a CDN, or if you can just push it into Nginx or something like that, or Kong or whatever it is, that's that front as far forward as you can get it, which is more your area. But if you can do that, it solves the problem. But then, so that eliminates a whole class of people that say like, well, we need to serve the HTML for SEO reasons. We need to serve the HTML for performance reasons on the client side, and it solves both of those things.
Yeah, but I think the client side is still, if you think, for example, about, I think one of the greatest thing, and I'm very biased probably there, but React Native, right, which kind of doesn't allow for any server-side rendering, right? It's just like, mobile side render on you render it on this device, right? And I think that's a kind of very elegant way to define what is the separation of concern. I think React is mostly, I see React more as a very kind of functional framework to basically elevate the concept of components, right? Which, like you said in the beginning, the terms components is a little bit, I don't know how to probably say it correctly, but the terms component is a little bit misused, right? Because it's like the term classes, right? It's like you use it just because it's in your glossary and you say, oh, it's a class. But at the end of the day, I think that the value of components in large-scale organization is accelerated and is elevated at the same time by like micro front-ends, for example, right? That are so popular in the past couple of years. Are the new microservices are the micro front-ends, and then probably in a couple of years we'll get another micro stuff, micro databases, for example. I don't know what's going to happen in the next 2 years, but I think micro front-ends and React are kind of very interesting, match
Yeah, I think the one key thing that React brought to the web was componentization.
Yeah.
And it's what the browser standards have been trying to do. They were trying to do it. They changed the way that they changed what standards committees were doing with browsers. Started to do web components and things like that, which still isn't fully there. And the rest is really just API choices in React. But the componentization aspect, that was a breakthrough, and it changed the way that a lot of us thought about it. Before that, the newest modern thing was two-way data binding with controllers as MVC and on the client side, and that turned out to be like great for demos. You could do really fast demos with that, but once you started to try to scale that up, it became really difficult to debug. So the componentization aspect, I think, should really never go away. I think it's the best of many worlds, and this is why you see newer frameworks using components as well, and it allows us to abstract away from the details of whatever we're implementing in the browser, so that we can think about how these components are shared within an organization. And that's when you have things like design systems coming in, and those can be very interesting, and then they're very cool, but they don't solve the problem of logistical complexity. They help facilitate discovery. They help facilitate branding, and to a certain extent reuse. But both you and I have helped organizations that already had design systems with components, and it wasn't enough, because unlike with microservices, you don't have a discrete boundary. When you're working on a microservice and you deploy it, that you can't break across a boundary. So say if you coming from a Java background or something like that, and you're deploying a monolith, there's always ways to break the rules of whatever the architecture is. But when you're using services, that's much harder to do. So hard, in fact, people don't do it. And so we don't have that with components. So the components allow the abstraction of the way we think about things the same way that microservices do, but they don't have that discrete process boundary that essentially solves people issues. The most interesting thing that's come out of the last 10 years for me is that some people issues, some organizational issues can be solved with technological solutions. Another example is linting. When you have a linter that's enforced at the CI level, it changes people's behavior. But before that, you couldn't get people to standardize.
Yeah.
And it's the same with microservices. So this trend towards micro front ends, and there's a recent thing when we saw it, we were like, man, that's exactly what we were thinking, was the Webpack module federation. It's definitely on the lines of what we're thinking. So if you've not heard of that, do look that up, because it's key for this area where you need to be able to have that boundary around components. And if you can think about it in a different way, again, this is at scale. So if you're in a large organization right now and you're trying to figure out, how do we collaborate better with other teams, and how do we stop stepping on each other's toes, and how do we stop duplicating effort, I think that the most effective next step is to have a cloud, essentially, of components that are actually deployed. And then when you're you're building your application. You still have your CI pipeline and all of that, but it builds something that the CI pipeline builds a consuming application from these clouds of components. So it can essentially be something that consumes a bunch of components into itself, packages those up into a browser JS bundle and potentially HTML, and then pushes those to the edge if possible, or at least caches them or whatever. Then you can deploy into that cloud of components a new component or a component update, and you've got versioning and all of that in there. And these consumer applications can then automatically pull that in, or they can have controls that only pull it in after manual sign-off, however you want to do it. But that can deliver some of what microservices give you and solve some of those logistical problems by making it more sort of something we just say, right, I'm just going to throw my code into this big cloud, and now people can consume that, and people can consume it in a way where I can't violate those component rules. I can't change the global prototype so easily and things like that.
Yeah.
And you can have checks for doing that and all that kind of thing. So you still need the people that then say, well, why do we need CI? So you still need the CI. What I'm saying is a live deployed environment of components that can be consumed live by applications is a step after CI that allows the sharing and the discovery and to some extent the process boundaries that you get with microservices to come into play.
Yeah, and I mean, you're touching one of the things that I kind of that I love, right? So I kind of advocate for the so-called service mesh since when was it? 2012? Yeah, when I built it in Amsterdam, right? For a company called Ice Mobile, we were building this large-scale solution, and we thought that we needed something that was an overlay network and that could kind of orchestrate all these things. So and without promoting, where I'm working now directly, but that's kind of the vision that I'm trying to kind of push forward. That is, and you just touched it, right? So I think we kind of passed the time of stitching, right? So all this compilation part that is very static, very
right.
That creates this kind of overwhelming processes within organizations, right? And so we are in the world where the mesh is not a service mesh anymore, right? As if you look, we have serverless, that is some sort of conceptualized, mesh where things that are, because it's purely event based, then you don't need directly to connect pieces that are loosely coupled. And so I think where we were going at the time was to basically define this concept of we took it probably to the extreme with a system that was highly based on a graph that was based on this concept of consistent hashing to kind of self-balance and distribute dependencies and so on. But if you look, I think the concept of mesh is coming to a point where I think micro frontends are just like the beginning of this new phase. And I think even Federation is starting to kind of poke this idea that components then needs to be loosely coupled, and there will be some sort of overarching control plane. I deeply believe that the model of the mesh can be implemented everywhere. Right? Imagine having some sort of sidecar inside of your components. And that's what we built at the time. Well, you built, I just helped with the math behind it. But it is basically, you basically kind of subscribe and notify. Yeah. And then you have a control plane which orchestrate and rebalance and, version injection. So we had this inversion of control system. But I think it's so elegant, right, where we are going. I think React gave us basically a primitive that is now getting obsolete as a framework, but we are coming down to this kind of atomic particle that is the component. Now this component will explode into this, quantum theory, where we are going to have this new version of a component that is going to live on this component mesh.
I like thinking of a component as a primitive. That's real nice. I think that I know this is a React conference, but the focus should be less on React and more on how do we move forward in a componentized world. You have a lot of organizations that still are using Angular 1 and 2, and there's a lot of code that's been written, and you know, the entire industry has had this criticism many times, which is the amount of, it was actually until React, there's a lot of criticism about churn, about we'll go from this framework to that framework to the next framework. And now we've been, React has won that war, I think, for quite some time. But another way to, and so one solution to churn is to go, let's just pick a framework and we'll all stick with the same framework. But in reality, in practice, that's not really how things go. And so if we could think about
the pipeline, Dave, sorry to interrupt. It's like you touched it, right? So the problem is that nowadays in 2020, we're still too sentimentally attached to a framework, and instead of detaching, like we were saying, right, and look at the primitive and say, do I really? So cloud actually took us in that direction, right? So to kind of sentimentally detach from hardware and transforming basically hardware into a commodity. If you think you just click of a button, you don't care that it's Dell, HP, or whatever, you know, Amazon, you know, Azure, GCP, whatever else is gonna come, will give you a machine, and you don't care. The same thing, I think it's, and that's why I think it's so elegant to what you just also said earlier on, right? That React is fundamentally introduced the concept of components and all the kind of reactive model, right? So if you think about hooks, if you think about then how GraphQL took this concept to the next level, doing this kind of live bindings, right, through subscription, which is super elegant. You basically kill WebSockets as a concept, and you just work into this kind of more duplex way on, you know, leveraging quick, hopefully, when it will be released, or like, you know,
I mean, yeah, it's going to be some years yet still.
But I think it's super elegant, right? And it is de-risking organization, because if you think about the primitive, you and we take a step back and look, and also, you know, I'm kind of invoking here all the front-end developer and everyone, you know, using React. Just, I understand that there is a framework, but if we kind of for a second take this beautiful trip 10,000 feet up in the sky and look at the problem and say, nowadays major enterprise, they're still discussing what a component is, right? So, and I mean, I can tell you many stories in Talos where we had lengthy and very expensive meetings to discuss, is a component a widget, or is a component a button, is a component is a screen, is a component.
Yeah, but this thing about the components as a primitive, and thinking about it that way, there's two kind of thoughts about when code has been written. There's two what seem to be contradictory things. One is that we say, you know, the sort of modern code development, you should be able to throw code away. You shouldn't be attached to code, right? And that is true in that you should try to write less code, not more code, because less code means less bugs. Generally, don't try to be too clever and too terse or anything, but like, it's okay to throw code away. On the other hand, you have, you know, code is an investment. People have often paid for that code to be written, right? Yeah. So they seem contradictory. But I think what it is that you have business logic and then you have technical implementation. And the implementation of business logic is the thing that has value, and the actual implementation details are less valuable. So when we say, oh, we use this framework or that framework, that's implementation details. But what's contained within a component is often business logic, unless it's like a higher order component or something like that wraps things or whatever, but which is implementation details. But when you have components that contain business logic written, say, in Angular 1 or 2, what you want to think, what people are thinking about is like, how do we move this over to React, right? in a post React world, that's going to be easier because it's more like with Angular, things are written with controllers and models and views, like the old school Angular. I mean, and so there's more work to be done to like say, well, I guess we kind of make the directive kind of a component, and we sort of wrap it up that way. But you know, if we can start thinking about components and even writing components in an agnostic sense, or at least in a sense of like, well, how would we use this for something else? Like, I think that's a really interesting step, because now your investment is preserved, but you're not attached to the implementation details so much. So you're not beholden. The reason we talk about saying like, oh, you should be able to throw code away, is so that you're not like locked into that, and you're not locked into technical debt.
Yeah.
And so if you can, the more we separate in our minds the component from the framework, the easier it's going to be flexible in future. I think that's the message I want to send out today.
I agree. I mean, once again, for anybody checking out what CTO.ai does, I believe in our mission statement. The world belongs to workflows that are made of reusable pieces, right? I think in 2020 we are wasting way too much time and money rebuilding the same user management system, right? And Auth0 is not the solution. Cognito is not the solution. Many other things that are not the solution. The solution is that as a developer, right, I want to invest more into what is valuable for my business and my next phase, more than rebuilding something that a million other people already built. And I think my message for today is to kind of be provocative in that sense and say, what is the next phase for a framework like React? What is the next phase for these primitives, right? How can we kind of avoid to rebuild the same thing over and over again, and just like think about this marketplace, right? I'm a very bad front-end developer probably, but I'm a bad developer in general. So I'm lazy and I want to just do things that somebody already did. I'm not interested. I just want to build something new, something, edgy. And I think if we do in this way, we enable this kind of mechanism where we look into evolving code more than iterating on the same piece of logic over and over again, right?
Yeah, and even from an industry perspective, I think I think we are starting to, and I think we do need to mature in the sense that we need to be thinking about the bottom line, which is the business logic, and not so much about reinventing the implementation concepts and things like that. But at the same time, if we can make our lives easier and we can take advantage of code that business logic code that's been created, then we should do that as well.
No, 100%. I'm gonna say something that probably is gonna get the whole audience against me, but I think in certain we are going through this iteration where we are taking a step back, but because we are preparing to make this leap for 2 steps forward, right? So I'm very positive there. The world of components, Microsoft and other, ISVs already kind of dominated with, infragistics for whoever coded in Visual Basic or in .NET, making that grid that everyone was using, right? Because they nailed it. They said, if we build a component that can be reused by everyone to solve these business problems, they can focus on feeding this grid and, announcing the grid over and over again. And, I think we are ready for that phase. And I really believe that the future belongs to 2 things, a kind of transversal and cross-cutting mesh where, the service mesh goes into the business logic mesh that's what I'm fighting right now, is like building workflows that can be reused. And then I think the future is there for having this component front-end mesh where, and I think that you will see probably in 5 years, I don't know when, right? But there will be this universal control plane. And so our applications basically will become like this stitching together, putting pieces together, and then we will be able to not care about all these non-functional requirements like I mean, you are the creator of one of the most famous loggers, if not the most famous, so you know exactly what I mean. But the main thing is, you know, logging is a solved problem, right? So you build Pinot. Exactly. Nobody should write a new one. Just use Pinot, right? If you're using Winston, just drop it. It's old, doesn't make sense anymore. Use Pinot. It scales. Don't reinvent the logger. Don't waste your time. Build something better, but not a logger. Like, don't build something that is already there, right? Just try to challenge what the next evolution is. That's probably I think we're running out of time.
Yeah,
but
I think that's our time, but we'll be back in the Q&A in 2 hours, right?
Yeah, if I'm not.
If you're not asleep,
if I'm not
I might go back to sleep.
Well, thanks everyone for listening to our chat. And by the way, this is what basically we do almost every morning. So,
and if you have questions, come back to us, and we'll be happy to dive into any details in the Q&A.
Definitely. And I think you are muted.
Here I am. Can you hear me?
Yep.
Perfectly.
Great. And thank you guys for this incredible chat. And for me, you seemed like two old best friends that met late at night. I hope that our viewers got lots of information during this chat. Thank you very much. And we have another speaker waiting for us. So I need to say goodbye to you guys. And actually, we can meet you at the Q&A session if you have more information to share.
Lovely.
Okay.
Okay. So, bye, guys. And the next topic we are going to talk about is Reduce. Get rid of your reducer boilerplate. And Richard and G will cover this topic for you. Richard is a software engineering coach and coding teacher trainer. He's worked with many initiatives helping underrepresented groups get into tech. Code Your Future, Coder of Color, White Hat, and Black Coder. Professionally, he's a coach developer. He has coached developers at consultancies, startups, and multinationals, including Public Sapient, Starling Bank, and Improbable, trying to gather his background in teaching edtech and startups. So, welcome, Richard.
Thank you, Anna.
So, I'm happy to see you here on our conference.
Delighted to be here.
So if you're ready to share your screen to start your speech, so you can tell us, and
Absolutely.
we'll help you with this.
So, yeah, thank you all for joining. I'm here to talk to you about, exactly like Anna said, reducers, state management, boilerplate, and getting rid of it. So this is for you if you use hooks. So maybe you use reducer, or you're interested in using reducer, or maybe you use Redux. In both cases, you have to think about reducers, and that comes with boilerplate. And boilerplate, if we can minimize it, it's great, we can. So with this library, Reduce, with just 2 lines of setup, we get state management that is type, flexible, and scalable, and it plugs into either use reducer or into Redux. So that's what I'm going to be showing you today. And as a bit of background and context, we look at the state of Frontend survey. This came out quite recently, and you can see that React hooks and context, along with Redux, are both way ahead in terms of what Frontend developers use for state management. Just under half use at least one or the other. They're not mutually exclusive, some use both. And the way that the report wrote this up was quite interesting, I thought, where the report said, oh, it's like this major change is happening. People are kind of going to hooks and context over Redux, which I think is maybe an unhelpful characterization. It makes it sound like there's this sort of thing where you've got these developers who use Redux and suddenly they're like, whoa, use reduce, use context. Like, yeah, I'm going to use that. And they actually, you can use both. So they've got different use cases. So if you just wanted to try and solve prop drilling and pass your props down to deeply nested components, then use reducer and use context will be great for that. If you want to do complex asynchronous logic, personally, I really like Redux Saga, and so Redux gets you access to the Redux ecosystem. So there's different choices based on different use cases, and I'm not here to say use one or the other. I'm here to say, well, whichever you're using, there's some really interesting stuff in common in terms of the reducer boilerplate, which we can optimize. So this reducer boilerplate basically comes from the Flux architecture, which both have their origins in. So Redux was explicitly an implementation of Flux architecture. Use reducer is explicitly inspired by Redux, so they can both be traced back. Flux architecture, here's a quick diagrammatic overview from Facebook. It's sort of developed as an alternative to model view controller. I'm not going to dwell on this too long, but in essence, the important things here is view as a function of state. We have actions that happen, and these actions go into a dispatcher, and the dispatcher's job is to take different incoming actions and pass them through to a store, which holds the current state. It looks at incoming actions and it updates state, and therefore, because state is updated, view updates because view is a function of state. At a sort of higher level, I know this can feel quite abstract. When I first looked at Flux architecture, I was like, I'm not sure I completely get this. So here is kind of, in essence, the skeleton of Flux architecture with Redux and use reducer, where regardless of whether you're using Redux or whether you're using use reducer, in both cases, you've got a reducer you pass in, and where that comes from will come to you later. And in both cases, the things I want to focus on, you get back two things: a way to read state through either the get state function or a state value, and a dispatch function, which is a way to update state. And then you update the state by passing in some action. And that action flows through to the reducer, which looks at state, takes the action, and then updates, returns a new value of state. And so following this sort of reducer function signature. So Redux and use reducer are doing the same thing in terms of Flux architecture, giving you a way to read state and a way to update state through a dispatch function. And what you can see really drives it is the reducer and the actions. If you don't have a reducer, then neither works. Both require a reducer as a fundamental engine, and both require the actions to really drive changes in the reducer. So what that means then is, if we think about this, and every time that new state management comes out, I think people are like, whoa, maybe I don't have to use Redux anymore because I can use this new thing. And I think this comes from the fact that Redux has a bit of reputation for having lots of boilerplate, high learning curve, lots to maintain, very verbose, maybe tedious. And so when new state management kind of techniques come out, people are like, great, maybe I never have to write all this Redux boilerplate again. But what I think use reducer shows us is it makes it clear this boilerplate is actually Flux architecture boilerplate. It's not Redux per se. It's boilerplate which comes with Flux because Redux is based on Flux architecture, and use reducer is also using Flux architecture in terms of your reducers and your actions. And so use reducer and use context doesn't solve at the core the problem of reducer boilerplate. It's not trying to solve that problem. It's an implementation of Flux architecture. But I find that boilerplate super, super boring to write and maintain. So I think there's a better way to do it. And here's how we're going to kind of go through this talk through like 5 emojis, 5 stages. So firstly, ouch, is we're going to look at what does that typical reducer boilerplate look like. And we'll see why maybe it's frustrating. Then in the ooh section, I'm going to show you how we can use reduce. And it's literally 2 lines to get rid of all your boilerplate. Then gosh, we're going to look at some more advanced usage of the reduce library. So the default stuff gets you quite far away, but maybe you want to do some more advanced stuff. And that's in this section here. Then in Whoa, we're going to look at TypeScript, right? Because that's a question now. New library comes out. Does it work with TypeScript? Well, reduce is first pass TypeScript support. And this section is also going to be accessible, even if you never use TypeScript. It'll be in a way which I hope you can understand. And then if we get time, which I suspect we won't, but if we do, we'll look at building a React app with Reduce and use Reducer. So to begin with, just a heads up for that boilerplate, which is coming in. This is not the way I necessarily recommend you write your code, but this is just a tour of, well, how do we do this boilerplate at the moment? So here, let's say we're at a conference. So I'm going to control or manage some conference state. And let's say this is actually before the pandemic. So my conference state is going to have a venue, and my venue is going to be open. And unfortunately, at the moment, my venue is not accessible. We're going to fix that later. And my venue also, or there's also maybe a number of attendees, which let's say it's a very popular conference. Let's say it's 9,000 for now. I have my conference state, and we notice the problem. The problem is that it's not accessible. So we're going to think about how can we update this state, but we want to do this in a Flux architecture way, which follows a flow for use Reducer and for Redux. In this particular demo, I'm going to use Redux. It's slightly easier to demo line by line, but the exact same thing would work for use Reducer. So I'm going to import from Redux the create store function. And I'm going to kind of sketch out what this looks like. So with create store, we pass in some Reducer, which we don't have at the moment. We're going to have to get that at some point. And that gives us back the two important things which we want to use for Flux architecture: a way to read state and a way to update state. We read with get state, we update with dispatch. And at this point here, once we've got that, we should be able to read our state. And when we read it to begin with, the venue is accessible. That should be false originally. Then we want to update state somehow. And after we updated state, then when I look at the venue and I check whether it's accessible, I hope that this is now true. And in the Flux architecture, the way that I'm going to update state is going to be by dispatching some action. And if we were using use Reducer, then it would be const state dispatch equals use Reducer. So again, you can see that it's the exact same pattern, really. Okay, so now we've kind of got these two gaps to fill in: the Reducer and the actions. And remember, these are this is the engine that drives the Flux architecture. And this is now the typical boilerplate way that you might write your Reducer. So I'm going to say my Reducer is a function. It takes two arguments. So it takes some previous state and it takes an action. And in Redux, we default this to your initial state. And the classic way of writing this is we do a switch statement over your action type. If you've not seen this before, don't worry, we're going to kind of scrapple with boilerplate later anyway. And by default, we're going to return the previous state with no changes. But I'm interested, I want to make the venue accessible. So I'm going to write a case to do that. So I'm going to say venue made accessible. And in this particular case, well, I need to not mutate my state. So I'm going to need to spread out everything from conference state, then go into venue and spread out my conference, sorry, my previous state, that should be. Spread out my previous state, and then spread out my previous state.venue, and then is accessible. That should be true. And this is a little bit ugly. You've kind of got that kind of spread hell thing, but it's okay. And now I can stick that Reducer in here. Now, indeed, I get my venue.isAccessible. That's come out as false. Great. Now I need something to dispatch to it. I'm going to do it in the classic action creator way. And I'm going to write a function, therefore, make venue accessible. And this is going to be a function that just returns me an object with type venue made accessible. And I'm now going to stick that here, make venue accessible, and execute it to create the action. And now I get that as true. So this is the classic sort of boilerplate way of doing it, where you've got your reducer you manually write and an action creator you might write. And this is okay for one case, like we got it to work. But actually now the pain point's going to arise when I want to do more stuff. So let's say I also want to close my venue. So I want to, at conference state.venue.isOpen, I want this to be false. This feels basically the same as what we just did. You know, it's really, again, quite simple to describe. So what I want to happen is I want to get state, when I read venue.isOpen, currently it's true. I want to dispatch something. And then when I read it after, it should be false. But now in order to actually make this go through, I need to make loads of changes to my engine, actually. I need to now add another case in. Case venue closed. And I need to turn, and this is really, really repetitive. And I'm actually really bored writing this out again, because I just want to make the changes happen. Is open, false. But then I also need an action creator, const close venue. There we go. And I'm going to return type venue closed. And now I'm going to stick that here. Close venue. And that's not working because I've made a typo. Fine. Okay. That was really boring and tedious. I didn't enjoy that at all. And now let's say I want to now increment my number of attendees. Again, that's going to be so tedious. I'm going to have to write another case statement for that. And this kind of logic, which is really simple, it's really simple for us to describe how we want our state to change. You know, I want this to be true. I want this to be false. I want that to be true. I want to increment this. It's easy to describe, but there's so many hurdles for us to jump through in order to actually get this working with this sort of boilerplate of our engine. So I'm not a fan of that. And this really made me think, well, what if we could get rid of that reducer boilerplate? So I want this to be something where I don't feel like I'm jumping through hoops, where I can just, if I can think about the changes, I can just make them happen. So I can concentrate on actually building out my UI. And I want this to scale flexibly as well, where if every time I add new things into my state, I don't really want to be adding in new cases, because that's just boring. And that means as my state grows, my boilerplate grows with it. I want my boilerplate to be something I write once and I just forget about it. I never have to touch it again. And I also ideally want it to be strongly typed so that I can use it nicely with TypeScript. And that's why I wrote Reduce. So whether you're using Use Reducer or Redux, then you will find that this is going to give you zero hassle setup, it's going to scale flexibly, and it's going to be strongly typed. So let's look at the first of those benefits then, zero hassle, where it's 2 lines to set up, and then you can reduce anywhere in your state tree. So let's go back to all this horrible, horrible boilerplate, and I'm literally just going to delete all of it. Like, get rid of that. And these here for now, I'll leave as empty objects, but we'll delete them shortly or get rid of them soon. And 2 lines of setup. Okay, here we go. I'm going to import reduce from reduce. That's line 1. Line 2. So I've got my state, right? And I'm saying, well, I just want my engine. Just please give me my engine so I can drive changes. So if you pass your state to reduce, reduce gives you back your engine, which remember, it's 2 things. It's your reducer and your actions. They drive Flux architecture, but they're painful to write. So actually, wow, if we could just get back a reducer and get back some actions, that'd make our life so much easier. And that reducer, we can pop straight into the kind of either use reducer or create store. And now let's think about these action creators, which before we had to write the case and get it to talk to our reducer. But these 2 things, they're a pair. They already talk to each other. And so you no longer have to manually wire them up. So what do I mean by that? Let's think about the change we want to happen with make venue accessible. What I would like to happen is kind of like I've got my state and @venue, @is accessible. What I want to do is I want to create an action and the action should make this Boolean state true. So kind of turn it on, let's say. That's kind of what I want to do. That's the change I'm describing. And reduce is going to make it super easy for me to do that, where I'm just going to stitch that together. State is undefined. But hey, what about this actions thing here? Let's use that. And make venue accessible is doing this. It's an action at venue is accessible. I'm creating an action there, and I'm turning that state on. And now, if you look, when I dispatch make venue accessible is true. So close venue, how would that work? So at the moment, we don't have, currently the venue's open, and we want that to be false. So let's think about the change we want to make. So actions, it traces out your state tree. So actions, where do I want to make the change? In venue, not at is accessible, at is open. That's what I want to change this time. And there I want to create an action, but not an on action this time. I want to create an off action because I want to turn the Boolean state off. And now when I close venue, state venue is open, now it's false. So let's look at some more examples of that. And you actually don't have to, you could abstract into functions like this, but you could also just do it directly. So what I mean by that is, let's now look at attendees. So get state.attendees. Currently it's 9,000. Now I want to increment some states. I want to increase the number of attendees. Before, I would have had to add a new case into my switch statement, would have had to write an action creative if I wanted to. I don't have to do any of that now. Now, I just describe the change I want to see. So actions, not in venue, but at attendees, that's a number I want to act on. I want to create an action to increment. I'm going to execute that to create the action. And now if I look at state.attendees, that's 9,001. It's been incremented. What if I want to increment by a larger number? Well, I can just pass in an argument, 500, and now I'm incremented by 500. And I said you could reduce anywhere in your state tree, and it's going to scale. So let's add some more state in. Let's add some announcements. And we'll start off with just a hello world announcement. So now let's take a look at that. So now I'm going to look at my announcements. That's an array hello world. So again, it's super easy to describe the change I want, and reduce makes it easy to create that change as well. Where if I want to create a new announcement, I change my state, and already I can now just immediately start driving my Flux engine, actions.announcements. I'm going to create an action there. I'm going to push something, and I'm going to push something like reduce is cool. And now, if I look at my state announcements, hello world, reduce is cool. Let's maybe make this nice in caps, reduce is cool. So I was there acting on the array, but reduce lets you act anywhere in your state tree. So maybe I want to act on hello world. So where is this in my state? It's inside actions.announcements. It's in that array, and it's the 0th one. And I want to create an action to act on this string, hello world. And I want to maybe add some exclamation marks. So I'm going to concat a bunch of exclamation marks. And now, when I get state.announcements, hello world has the exclamation marks. So reduce gives you back this reducer actions pair. The reducer plugs straight into create store or use reducer, and actions knows straight away how to talk to its reducer. And you just describe the change you want, and you can act anywhere you want. So that is the basic zero hassle setup of reduce. 2 lines, and you can reduce anywhere in your state tree because you've got the reducer and the actions to really drive those changes. Now we're going to look at more advanced usage of reduce. We're going to look at how you can scale this more flexibly. So what do I mean by that? So let's say that in my announcements, maybe I want to shout or yeah, hello world. Let's get rid of this action here. So currently, the 0th element, hello world, is a lowercase string. And I want to do something like, I want to shout that string, where ideally it'd be something like actions.announcements.create.shout or something like that, where what it would do is make this an uppercase string and add some exclamation marks. And now Reduce gives you lots of defaults. It doesn't give you like anything. It gives you sensible defaults to get started. But maybe you want to do some custom stuff. I just want to do something here. I want to do something, sorry, not an announcement. I want to act on announcement 0 because I want to act on that string, not the array. So that's the array, but now this is a string. So on that string, I want to do something to it. What do I want to do? I want to make it uppercase. And I want to add some exclamation marks. And now if I look at getState.announcements, hello world is uppercase with exclamation marks. So this means that you shorten the loop between here's a change you want to make in state and you made it happen. If you can describe it, then Reduce lets you just do it and just get on with it. And maybe I really like the shout thing, actually. You know, I'm really happy being able to shout this, and I want to shout Reduce is cool as well. So let's go back. Let's make it lowercase. Reduce is cool. And just like I shouted, hello world, I also want to shout Reduce is cool. And now I'd risk repeating myself by repeating this sort of thing. Do this. When I'm doing it more than once, I'm like, actually, it'd be nice if I could have that as a reusable thing, which just plugs straight in. So we're actually going to do that. So I'm going to write a custom reducer. So I'm going to say shout. I'm going to take a string. And I'm going to do exactly that. I'm going to return string to uppercase with some exclamation marks. And this should work for any arbitrary string. And I'm going to tell Reduce, hey, here's my state, but also here's some custom behavior I'd like you to be able to do. I'd like you to be able to shout stuff. I'd like you to be able to shout strings specifically. So now let's go back to this. Rather than doing a do here, create, now I can shout. And it wasn't there before, but I've added it in. And now that means I can repeat that. So I can also repeat actions.announcements 1. I can create a shout there and log out my announcements. And hello world, Reduce is cool. So this is what I spoke about before with the write once, reduce anywhere. You write some arbitrary reduce logic and then just use it anywhere in your state tree. So that's looking really great. Maybe also I want to make an announcement about the number of attendees I have. So this would be something like, we have 9,000 attendees. I want this to be in my announcements array state. And in reducers, talking between different bits of state can be fiddly. But Reduce makes it really easy. So actions.announcements, I want to make a change to this array. So I'm going to create an action there. And I want to do something. And I want to take my kind of array state, which is my announcements, or I might call this my previous state. I also want to look at my tree state. I'm going to spread out all of my previous state. I'm spreading out all of my previous announcements. I'm going to add in one new announcement and say, we have some number of attendees. And what number? Where is that? Well, it's in my tree state at attendees. And now when I check out getState.announcements, hello world, Reduce is cool. We have 9,000 attendees. So Reduce also makes it super easy to talk between different parts of your state, your tree state, which you might need to do. What else can we do? Let's say we are looking at, we're ordering in some food for our attendees. We're going to get in some pizzas. We're going to get in some margaritas, and let's say we start off with, say, 20 of those. We're going to get in some pepperoni pizzas. Let's say we start off with 10 of those. We're also going to get in some sushi. And let's say we start with some nigiri, and we have maybe 100 bits of nigiri and sashimi as well. And we say 120 bits of sashimi. I'm going to get rid of all this. Now, I have my margaritas, I have my sushi. Let's just look at our food state at the moment. We've got pizzas and sushi, and these are going to get eaten, you know, so people are going to eat our pizzas. I'm going to need to change the number of pizzas I have. And here's what I'd like to do. I'd like to do something like actions.food.pizzas.create, and maybe all pizzas are going to go because pizzas are popular. So I want to create a set all values to 0, maybe something like that. And then when I look at that, all pizzas, margherita and pepperoni should both be 0. I'm just going to quickly write this one myself. Set all values to 0. Take some object state. I'm not going to walk through my logic here, but basically, I'm going to take the keys of that state. I'm going to map those keys onto entries. Each key is going to become an array of key 0, and then I'm going to return my object from entries. The logic's not the important thing here. The important thing is kind of what happens when I pass it through. Set all values to 0. So this now works. This sets all values to 0 in my pizzas, and it means I can reuse that for my sushi as well. So I can do actions.food.sushi.create.set all values to 0. And log get state.food. And at this point now, both pizzas and sushi, all keys are 0. All values are 0, sorry, I should say. However, this isn't super reusable, because what I'd like to do is something like set all values to like 5 and set all values to 10. And that's more reusable, right? So how would I do that? Well, let's go back to our custom reducer, and there's previous state and action, right? And when you pass arguments through to action creators, by convention, they end up as action payloads. So I can stick that down as action payload. And I need to rename this function. And now set all values to 5, pizzas, all values of 5, set all values to 10 at sushi. Now all values are 10 in my sushi state as well. So that is the quick whiz to the advanced usage of Reduce. So it really scales and lets you input in custom behavior and write once, reduce anywhere. The next thing I'm going to quickly show you is how this works with TypeScript. So let's look at our announcements, for example. Let me just ditch this all again. My announcements, maybe I would try dispatching and putting something in that. So my announcements, I'm going to create a push. I'm going to push a number of like maybe 74. And TypeScript, because Reduce is written with TypeScript, is correctly warning me that, hey, what you're doing here, this is a number, but this should be taking a string. Why should it be taking a string? Because this is an array of strings. And a number doesn't belong in an array of strings. If I were to change this to be an array of strings and numbers, then Reduce is like, okay, fine, it's an array of string and numbers, so it can take a number. Or alternative with TypeScript, I could kind of say this is an array of string of numbers, and then this works. Let's look at the custom stuff. So if I have a new kind of like shout all, where this should work on array of strings, I'll type it later. What I want it to do is return my array of strings, and I map each string to uppercase plus exclamation mark. So I want it to act on an array of strings and shout all of them, basically. And I'm going to use TypeScript and say that is an array of strings. And then I'm going to put that in here, shout all. And now let's try and do that. let's just actually have a look at our announcement state first. Hello world 74. If I try to dispatch actions.announcements.create shout all, this is going to actually say, TypeScript is not letting me do this because announcements, shout all is going to cause a bug if it runs into an array of strings and numbers. Because if I call to uppercase on 74, it's going to throw an error. So TypeScript's saving me from making that mistake. So if we're like, okay, maybe this isn't an array of string of numbers, it is just an array of strings, and I shouldn't push that. Let's just comment that out. Now I can shout all. Get state dot announcement. And if you see, it's let me do that. It makes this available on any state where the state is an array of strings, but it won't let me do it elsewhere. So if, for example, on venue, actions.venue, which is an object, if I try creating a shout all, it's just like, what are you doing? Array of strings.map, that's not a function on this thing here. So TypeScript stops you from making mistakes. And then it's really helpful if the power update with Reduce is if we look at food, pizzas, and create update. So what update does is basically replaces the state where you've got there. And I want to update and I say, well, we're going to have pepperoni 0. TypeScript's warning me. It's saying, hey, what about margarita? You know, your state here, I know your pizza state has margarita and pepperoni. So you give me pepperoni, but hey, you got to give me margarita as well. And I'm like, thanks, save me, TypeScript. You got my back. Save me from making an embarrassing mistake. And then I can check out my food pizzas. There we go. So that's a quick whiz tour through Reduce. And so you can see whether you use Reducer or Redux, you can just get rid of your boilerplate with Reduce. It's zero hassle. It's 2 lines to set up. Then you can reduce anywhere in your state tree. It scales flexibly. Let's use custom logic. You can write once, reduce anywhere, and it's strongly typed. Works great with TypeScript. I was going to go through the React demo, but I don't have time. I'm just going to wrap up by kind of, if you want to check out the documentation, it's that link there. And it'd be great if you'd start a repo. Like this is the first time I'm actually publishing the library to the world. So check it out, start a repo, tweet something nice. That'd be great. And I'll be in the Q&A for questions, but I will quickly answer some stuff now in terms of I see some stuff about the plugins that I'm using. The extension is called Quokka, Quokka. That's how I was getting the sort of like the live feedback, what's getting logged out. And then Reduce, just to install it, basically, if you go to check out the documentation, so let me just actually open this up to finish off. You open that up there, you'll see documentation, and you can install npm install Reduce. I'll be in the Q&A if you've got more questions. I'd be happy to talk about how can you use this with React and stuff like that.
Thank you, Richard. I was really impressed of your coding speed. Like, seriously, reveal your secret. How long does it take to code like this? Like, or maybe, okay, how long are you working on this field?
So the reason why I can type so quickly, I think, is actually I started by playing the piano when I was younger, which really helps, obviously, because you're playing the piano. And then, yeah, when it comes to that, just transfers really nicely to touch typing. So I'm lucky.
Seriously, so yeah, like you're seriously lucky. I know, like now I'm thinking about how much time you can save by this gift that you got.
Yeah, it is. Yeah, it's like because it's your brain and through the keys, it's just way quicker. It is great. So it's worth. There are sites you can do to practice your typing speed, which are also like quite good. So if you want to, get up, like you can practice and get better.
Thank you very much. And I see a few more questions addressed to you, and so we'll have a lot to discuss with you on our Q&A session. So see you later.
Yeah, right. See you later.
Bye. So the next topic that we are going to talk about is going component driven. And Gert Hengeveld is going to talk more about this. And a few words about him. Gert is a senior consultant at Xebia and has been building React applications since the early days. He is the author of React Async and a frequent speaker at Meetup. On the past, he organized the React NL conference. So, Gert, I'm happy to see you here. It's an honor to see you here on our conference.
Thank you. Thanks for having me.
How's your mood?
My mood is okay. It's good. I have a bit of a cold though, so that is a bit of a bummer. But going to get myself tested for corona. Unfortunately, I don't think it's going to be anything. But you got to be sure these days, right? So I do have to correct you slightly on my introduction. Thanks for introducing me, but I'm no longer with Xebia. That's actually an older bio of me that you probably still had in your system from a former CFP that I did. But anyway, I nowadays work with Chromatic, but I'll get to that later in my presentation. So.
Okay. So if you're ready, please share your screen.
I am. Yes.
Start.
Yeah.
So
all right, let's go. So thank you all for attending. I hope you'll enjoy this, and yeah, let's get started. So if you're a front-end developer, you are basically tasked with building web apps, screens, and features, and stuff like that. And your process can vary, but in general sense, you might often start with something like this. A designer comes to you saying, hey, we want this app or this website built, and the way that they are delivering it to you is in a sketch file or in an InVision prototype or something like that. So you're confronted with this wide array of design, of pages, screens, whatnot, maybe even components if they think that way already. But say you start with a screen like this. So you have this, your job is to build this one screen, right? Or maybe it's a new screen within an existing app. So how do you approach this? And the general approach that most people take is to actually start taking it apart, really, to just destructure, like decompose it before actually trying to build it from the ground up, really. How do you do that? So here's this example of the build screen in an app that I'm working on, and you can start composing it into sections like the header, the sidebar, the build header, the build summary in this scenario, and some comments that happens to be a feature on this page. So this, of course, varies wildly from app to app, from site to site, but you get the gist of it, I hope. So, and let's drill down a bit more into one of those features, like in this case, the build summary. So this is a general overview, kind of like a dashboard for what we call a build in our system. So you can now, if you've zoomed in this far, you can now start in identifying individual components on the screen. For most people, I guess this happens kind of naturally. Like, as human beings, we recognize patterns. So it starts to become apparent that we have some reusable, something that, like, they look all the same. These cardinal numbers here, they might just be one component that we reuse 6 times in this case. Or we have a button that we have 2 instances of on this screen. They might look slightly different, but they are both a button. A status bar, it's a unique feature on this page. But here, say badges. These badges, you'll see those all over the place on the web these days. So that's actually a very common thing to build and to have. I mean, probably you already have one of those in your current app or component library or design system. And then there's avatars, right? So it's basically an image with cropped to be a circle, right? Well, let me tell you, UI development, user interface development, or front-end development, it's a game of composition. It's all about taking apart these screens to like decompose them into smaller parts, right? Components. And then when you have all those components, you can start rearranging them and recomposing them into screens, features, screens, and finally like a complete app. So this is me. I'm Gert Hengeveld. I'm a software engineer at Chromatic, no longer with Xebia. I've been with Chromatic for a year now, and Chromatic is mostly known for being a company that maintains Storybook. So I'm personally mostly working on Chromatic, our platform, our SaaS platform, but I also occasionally work on Storybook. So actually, I'm currently working on a complete overhaul of the sidebar in Storybook with a new search and a new tree view, etc. If you'd like to know more about all that, I frequently tweet. I'm on Twitter, so please follow me if you are into this kind of stuff. So modern user interfaces, they are no longer really built from components. They are actually assembled from components, right? You less and less build something from the ground up, and more take what's already there and assemble new features, new screens, new pages. And this has a lot of benefits, such as the quality of your work will be better because you can verify that all your user interfaces work in various scenarios. And it's more efficient because you can reuse existing components. And give me 1 second. Yeah. And finally, and then speed, like you can parallelize the development of your user interfaces, your components, and your screens across people in your team and even across teams, which is actually a pretty big deal for big companies, because big companies have a lot of teams, and how are you going to like have them work together in a structured way and finally deliver apps and such that look and feel the same, and in a way that they don't like reinvent the wheel all of the time, right? If you have multiple teams building similar things, then it might be very beneficial, or it's actually very beneficial to reuse what's already been done, right? And finally, durability, because if you drill down all the way to components, you are able to pinpoint bugs at the component level. So, and then you can focus on this one component that has some sort of a bug and debug it, and check it for all the various edge cases and scenarios, and then making so that you can be sure that it's not this component that's broken, at least. So, but building components, it's complicated. It's not as easy as it sounds. I mean, I don't think it even really sounds easy. But consider this: you are working on an app and you're building a particular component that lives in this app. The typical, the old-fashioned way, I would say, of doing it is to build that right inside the app. So you have this app environment and you build a new page or screen right inside that app. That has various downsides, such as the data that lives in that app, that powers the features and the screens. That data is not always stable. Say you have your app connected to a staging environment or a local database that has wildly different data than lives in production, or even you run it against production, which you probably don't want to do. The data is going to change all the time, and it's not going to be stable. So if something breaks, it's hard to tell whether that's because some of the data changed or whether you actually broke something. Then there is the business logic that gets really entangled. So, because if you work in the context of a whole app, what you have to deal with is the business logic that surrounds it, such as like the state around it. Like, is this user signed in right now or not? Or what's the screen resolution of this particular user, or other like specific business logic. And if you have to test your component in all those various scenarios, well, that gets really hard to do manually. I mean, you're still going to have to do it. It's just a fact of the work that we do, but you can do it much easier. But we'll get to that later. And then there's unfinished APIs. So say you work in a team and you have front-end developers, back-end developers, and the front-end developers are crunching out screens, but in order to populate those screens with data, they need to have something built by a back-end engineer. Well, if you plan that perfectly, maybe that works out. But typically, that in real life, it doesn't work like that. So you end up like waiting for other engineers to finish their work, like their stories, before you can continue with what you've been doing, right? In my previous work as a consultant at Xebia, I was frequently like building screens and having everything finished, only to wait for a couple more weeks or months before the actual backend development was done, and before this thing could go to production. Well, that's a huge waste, because it's a huge waste if you do a lot of work and you don't deploy it to production, then you did it too soon. Doing it just in time is way more efficient. You want to get it out as soon as possible so that you can start learning from it. Like, is this the right user interface for the job? Like, do people get this? Here's where Storybook comes in. So Storybook, if you've not heard of it yet, it's a web application, but it's a tool for building user interface components in a way that makes it faster, easier, more reliable to do that. The way it does that is by allowing you to build your components in isolation. That means without this whole context of an app that it runs in. No, it's just you're looking at only this one component, and then giving you an easy way to catalog all your components in your system and all of their states. So a component can be in various states. So say we have this chart over here. It has like a default state here, but also an empty and a normalized state. And the great thing is it works with every major view layer. I mean, every library, Angular, React, and whatnot, Red View. You've seen them on a previous slide. So you get this component catalog. You can actually install add-ons to like make it fit your workflow even better. And the sandbox we'll get to. Announcement here is that we are actually, as a team, the team is working on something that we call the add-on gallery. So these add-ons, you can actually soon install them right from within Storybook. So we're working on like exposing them in a nice way, all the various community add-ons that there are, and like recommending the best ones, and so you can install them right from inside Storybook. So building components in isolation, that means you have this sandbox environment. It's actually just an iframe in which only your component is loaded, so you don't have to deal with all the state around it. Don't bother reading the source code, it's just an example, but this is general idea. And then you catalog various variants and states that, for example, this chart can be in. So that's what it kind of means to, what it means to go component driven is to start from your components. So it's actually it's a bottom up approach in that sense. And then you combine components to build bigger components. And finally, you use those bigger components to actually assemble the whole app. And then by assembling like the components and then adding the data that those components need to well, make it like meaningful. And Storybook actually it really kickstarts that workflow by giving you the ability to first develop those components in isolation, to build your component library, and then finally assemble your app. So here's an example of what it means to use Storybook. In practice, what you end up doing is you write these things called stories. It's essentially just a JavaScript file, or you can use TypeScript. It's a JavaScript file, and here's an example for a button component. So I'm importing my button component. I'm specifying a title for it, saying, oh, this is component/button. So that's actually the path to the thing, and then so that's the component path, and down there we have stories. So this button component has 3 stories. It has stories for the 3 appearances that it has: a primary, a secondary, and a tertiary. So like that could be like the primary is used for a call to action, so it's a pink button, and a secondary is like a blue button, which is like the typical thing you use, and a tertiary is something like it kind of looks like a muted down button, so it doesn't like jump out at you. So it's typically gray or something. So that ends up being something like this in Storybook. So you get this tree view in Storybook with your button and then the various stories beneath it, and it renders the canvas or the sandbox with just that component. So it's actually just the one button with this appearance and the label on it. So component variants, also known as stories, there can be a lot of them because what you should consider, and depending on the type of app that you're building, is variations of your components, such as the loading state, the disabled state, the in progress state. Say, I just clicked it and it's doing something. The error states, right? Or if in particular sense, like accepted, denied, or expanded, collapsed, depending on what kind of component it is. Say we have an expandable thing, then it might be expanded, collapsed. That's 2 states that this component can be in. So a lot of these goes for many components, say a loading state, for example. But those types of states are very often overlooked when you build a component right inside an app. You might get to them eventually because you figure like you are clicking through your app doing stuff and you figure, oh, we should probably have a loading indicator on this thing. Or, hey, oh, my database is down. I'm getting an error, but it doesn't show an error. Oh, maybe we should consider an error state, right? If that's the way that you're doing it, that is prone to like forgetting a lot of stuff. So it's better to approach it like holistically, as from a top-down view, considering all these various states. And then there's edge cases. So say I have a very long text in my component. How does the text wrapping work? Does it break my component or not? Or big or small images with the same thing. Or extreme numbers, which might like negative numbers where you don't expect one, or 0 or 1,000,000, right? What happens if you enter a number like that? It's actually very much the same thinking as when you're writing a unit test. I don't know how familiar you are with writing unit tests or tests at all, but if you have the mindset of writing unit tests, the way that you typically do that is by considering the edge cases of the unit that you're testing. So you go actually hunt for bugs by trying to find the edge cases, right? The 0 and the negative number and the very big number, that kind of thing. Or even missing data. So let's say the user has only just signed up for your app and doesn't have any data in your system. There is nothing there, the empty state of your app. Well, if you don't consider it up front, the first onboarding experience for your user is going to suck because they're like, it's completely empty. What does it do for me? What does it have to offer me? I have no idea, right? So missing data is actually a pretty big thing that you should probably be considering when designing components. Of course, it depends on the component, but and then special characters, say, I don't know, Chinese or something, if you're going to be localizing your app, or emojis, right? Things like that. What happens if you use those? And then there's context. Component in the end, like when it lives in Storybook, it lives in isolation. But when you're starting to using it in your app, it has a context surrounding it, right? So it might behave differently based on where it's being used, whether it's in standalone. Say I have a modal dialog and it's just in the page, but the content of the modal dialog can also be rendered as a widget, for example. So it can be standalone or composed, or the user is signed in or signed out, or the user uses a different language, or their location matters somehow, or the user is offline and your app supports working offline, then you have to totally consider that kind of thing. And the first-time user, I just already explained kind of. It might be very overwhelming. It actually is very overwhelming. And I'm not saying that you have to consider all these various things. It's just the mindset that you have to get used to. And it might feel like a lot of work, but you were going to be putting that work in anyway if you're trying to do your job right? The only thing is that you're just going to consider it upfront more, and hopefully or possibly this might affect the estimates that you give, right? It's no secret that estimates in software development often are wildly off. Well, one of the reasons is that nobody is considering states, edge cases, and contexts when building when estimating what to build. They only consider like, oh yeah, it's just the best case scenario, and all the rest we'll see what happens, right? And what if I told you that there is actually endless combinations of these things? So you can have combinatory effects on these. So that's where it gets more complicated. And actually, I don't really have the answer to how to do this properly. Let's look at an example. So we have this page title component or a build header component. So it has a default state, like the ideal state, right? But it also has a loading state. What happens if we don't have the data yet? Well, in this case, we render a skeleton screen. It's just a UI pattern. You can also draw a spinner. I don't know, depends on your app. And here's the example with the long title. So say there's a very long text in this thing. Oftentimes you don't control it because, for example, our app shows the title of a pull request on certain pages. Well, that we have no control of how long the title of a pull request is going to be because people enter it on GitHub and not in our app. And here's how that grows. This is an example, a real-life example of something from Chromatic. So we have this pull request check tooltip, and you can see it has over a dozen states. And that only compounds because these single items here, they can be like green, yellow, loading, errored, right? And then there's various variations. So at the bottom, you see the PR check and the MR check. That's something about context because we support both GitHub and GitLab. But GitLab talks about merge requests rather than pull requests. So we have to consider the fact that if they're using GitLab, then you show MR check rather than PR check because that's the lingua franca of GitLab. And so that's the kind of things. What does it mean? Well, we at Chromatic actually build the whole page in Storybook. So these are pages, screens that live inside Storybook, and all of the data that you're looking at here in the sandbox on the right-hand side, it's fake data. Is mock data. So if you're writing a story in Storybook, you are actually you are always using fake data, mock data. And that has various benefits. One of them being stability. So the mock data will never change, right? Because it's static data. That means that you can know for sure that it's going to be there. Always render in the same way. So if something breaks, you know for sure that it was your component and not the data that broke it. And you are able to go hunt down the edge cases. So I could say in my mock data, make this title very long or omit it altogether, right? What happens to my component? Does it break completely if there is no title? And you can actually see here that the screen is not built from the ground up. It actually is composed from various other components. Say on the left-hand side here, we have the screen in its various states, but it uses other components such as the reviewers, the participants, the header, the explainer, the components, which is actually a folder, the tooltip, which we just looked at, changes, change item, change comments. So, right, there's a bunch of things here, even like a scenario where we don't have a comparison yet. Build status tooltip. I'm not even sure where that thing lives, but it's all there in Storybook. So also one benefit here is that if I have to make an adaptation to this screen later down the road, I have to change something, I go in Storybook and I can quickly see all the various scenarios that are built there. So I have a complete picture. Right? Even if I'm not the original developer of this screen, I know all the various edge cases that the original developer considered when building the screen. All right, so you might be thinking, at least if you've done this before, there is some questions that people often have. So, for example, what if my component has internal state? Meaning, you can't just pass it some mock data. No, it has state. So a toggle, for example. So the general rule there is to separate your presentational components from container components. This is actually originates from a blog by Dan Abramov a long time ago about dumb components and smart components, or it was it was containers versus components, I believe, the original title. He changed the title actually a couple times. So in the end, it's presentational components versus container components, where presentational components, they are dumb components. They are pure components if you're familiar with functional programming terms, in the sense that they receive some props in React, but don't have any internal state or use context or whatever. They only act on these props to render a view. So they are pure components. And then finally, you write stories only for those presentational components and not for the container component, which would add the state. And so here's the example, an example of a collapsible view, right? You can click it to toggle open and closed. So we have a collapsible component which uses some state to say it's collapsed or not. But in order to be able to write a story for this, we actually want to extract the collapsible view component out of it, which is the pure component, so that we can purely based on props render this collapsible view in Storybook in both states, like opened and closed, right? So another question is, what if my component uses global state or context, or things like Redux, MobX, or Apollo, GraphQL, or stuff like that? Well, or React Router is another example, right? There's a lot of these tools out there that use global state or context to do stuff with your screens. The answer here is to use a decorator. You can wrap your stories at the story level, the component level, or globally in your whole storybook to provide them with the data that they need. That might be fake, that should actually be fake data. So we're not actually going to have an instance of React Router in our storybook. No, instead, we fake the React Router's provider to give them just a static version of what React Router would typically provide, such as like, what's the path, right? What's the hash of the URL, and where are we right now? Well, you can fake that just as much. And this is not something that we are only touting ourselves. There's dozens of teams, hundreds of teams doing this every day, all day, at big companies. Like, it's not something that we just invented out of the blue. It's been around for a long time. So actually, the question is, why is storybook development not on your LinkedIn profile yet, or your curriculum vitae? Because we think this is actually something that every front-end developer should be able to do. to work with, right? All right, so let's get back to all these various stories. So you get in trouble real quick with all these stories because it's a lot of work. Even once you've built them, right? You've built hundreds of components with each of them having a dozen of stories for the various states and edge cases and such. You want to test them all in the various browsers, right? You want to test it against Chrome, Internet Explorer, Edge, Safari, Firefox, whatever, and then in various viewports. So mobile, on tablet, on desktop. Well, this grows out of hand really quickly. You get so many variations of states and stories and whatnot. Well, this grows exponentially. There's no way that you or your QA colleague is going to manually test all of these states every time with every release. You would be spending weeks or months testing all of the various edge cases and such manually. There's just no way, right? So what happens if you follow the typical way of doing it is bug slip through undetected. So you have this component and it's applied on 3 pages. In the first page, oh, that looks good, right? It's in the sidebar, looking great. On the second page, it's on the right-hand side. Sure, floated right next to the text. And, oh no, in the third screen, it's actually right on top of an image. How did that happen, right? That's totally a bug. But if you right you make a change to an existing component and you don't consider you try to consider the various edge cases and you did your best to consider all the ways it could go wrong, but still we're only human, so we miss stuff. You click through the app manually before deploying it to production, and you viewed the first and the second page and you're like, okay, all good, go to production. But the third screen is like a screen that nobody really visits that often, so you missed it in your manual QA. Well, then users are going to be complaining, and you want to prevent that. The solution here is visual regression testing. The way this works is taking a screenshot of every screen in your app or every component in your app and comparing it over time. So you take a screenshot of your master branch, you have you build a new feature, merge it in, and again, before deploying it, you take screenshots of the same screens, same components, but after merging this feature, you can actually use visual regression testing to point out exactly what changed on these components. So once you realize this, you actually realize that when you write stories for Storybook to aid in your own development flow, you don't just get that benefit. No, you actually get tests for free, right? You're actually writing tests as you write stories. You just get that as an extra, right? So rather than having the former scenario, what you can do is say, oh, I applied this component in 3 screens. Left-hand side, oh, it highlights in green what changed. That looks good. It highlights in green what changed on the second screen. Looks good. Looks good to me, thumbs up. Third one, I am going to deny this build because it's clearly broken and we have to go back and fix it before deploying this to production. So this is actually what Chromatic does. So that's a tool that we build. It takes the screenshot and it lets you figure out about all the various visual changes that are there in your app over time. So this is the flow that you actually get. You test to detect the visual changes. Then all the changes that we found, you manually improve in Chromatic on screen, saying, okay, I compare left and right. Okay, new scenario, looks good, approve. You check your own work. It's a sanity check, really. And then you can merge this thing and be done with it, right? So you can actually ship your software with more confidence. But there's more. So UI development is teamwork. It's not just a single developer typically doing this stuff, right? You have a team of designers, product owners, QA engineers, right? So designers, they want to make corrections before something goes to production, right? I mean, they originally gave you this design to go from, and you build it, like you try to be pixel perfect, but it's not completely, and it might work out slightly different than the designer originally intended. So the designer typically wants to make some corrections before shipping it, because designers being designers. And then QA should be part of the developer cycle. I mean, typically what happens is that, like, if you have quality assurance personnel, they test on a staging environment, for example, right? You deploy it to staging, and then off they go for 1 week testing this whole thing, and then if they're done after a week with the thumbs up, it can go to production. With big apps that actually, and like enterprise companies, this might be months, right? Before, so there's going to be feature freeze for 3 months so that QA can do their job, right? Can test everything. Well, if you pull that forward into the actual development cycle, so before stuff get merged into in Git, then you can speed that process up. You can make the feedback cycle much quicker. QA personnel can find bugs before you actually merge this thing to production. And product owners, they want to be aware of what actually gets shipped, right? Product owners, product managers, they want to be aware of what they can tell their customers that has been delivered to them now, what the new features are going to be, right? And everyone wants to be aware of those new features in case, like, you have to do support, or you have to work, like you have to build new features on top of that. So it's good to have everyone on board with what's going on. So what you can actually also do is do the same process against pull requests. So where you compare two branches to visualize a pull request. So you have the master branch and your feature branch side by side, comparing like left and right. And you can have your peers, your team members, your designers, your QA personnel review everything that's going on before merging the pull request. So it actually becomes a status check on GitHub. If you're familiar with that, you have these checks that you typically use with your continuous integration pipeline. Well, Chromatic offers that as well. It just blocks your pull request from getting merged until someone has reviewed it and approved the changes that are in this PR. So you can actually visualize the pull request, not just in code, but in like screens as how they appear in screenshots. All right. So wrapping up, going component driven, it's about building one component at a time. And oftentimes you already have a ton of these components in the component library. You don't have to build everything from scratch. Then you combine these components to form bigger components, like create compound components, so to say. And finally, assemble screens and pages, and preferably also build those in Storybook. I mean, I know not a lot of companies are doing this yet. Like most companies, they just build their component library and their design system in Storybook. It's fantastic for that. But you can what if you would also build your entire pages inside Storybook and then apply this snapshot testing, the visual regression testing? Like, it's mind-blowing how much easier it gets. And finally, you integrate your pages into your app by essentially injecting the data. If you'd like to learn more about component-driven development, go to visit componentdriven.org. And thanks for attending. I had a blast.
So, thank you, Gert. That was strong and very informative. And please, can you hear me? Yeah?
Yes.
Please don't disappear. You will have a chance to answer some of questions addressed to you. And if there are a few of them, then you will get an opportunity to tell more about your topic. If some of the information remained unrevealed. So, see you later.
Thank you.
Bye.
Have a nice day.
So, the last finally, the last topic is going to be React hooks. Broke my test. Now what? So, Daniel Afonso, a software engineer from TalkDesk, is going to talk more about this and reveal this topic, do his best. So, hooks have become a better and cleaner way to write React code. Many are now realizing it and starting to migrate their solution from class to functional components. When the code looks great and the migration seems successful, your test may disagree. So, his presentation focuses on the common pitfalls of testing and what we have been doing wrong, while also teaching you how to test your brand new hooks using components, all this while using the React testing library. So I'm glad to welcome Daniel. Daniel, hi.
Hi, everyone.
Congratulations, you are our last speaker.
No pressure at all.
Sorry?
No pressure at all.
That's not a pressure. Like, seriously, you're going to be a hero here because I have no doubt that you have prepared a great presentation for us.
Let's hope so.
So we will check it anyway. So if you're ready,
Yeah, I think I'm sharing my screen already.
Mm-hmm.
Okay.
Mm-hmm.
So I'm starting. So the title of my talk is React Hooks Broke My Tests. Now what? So for those of you who don't know me, I'll start by introducing myself. My name is Daniel Afonso. I'm a software engineer at TalkDesk, and I'm part of the Innovation Lab here in Coimbra, Portugal. And I'm also an Auth0 ambassador. You can follow me on pretty any social media at the handle at Daniel JC Afonso. And my current tech stack my current tech stack is the JavaScript ecosystem, React, and in this case, which will be very specific to this talk, the React testing library. So what am I going to talk to everyone about on the next couple of minutes? So this talk is about migration to React hooks that showed me and my team that our tests weren't being done as we expected them to be. And this forced us to shift our mind process and the way we approach testing, while in the process of also getting to know the React testing library. So at the later part of this talk, after the story, I'll give a quick guide for the React testing library, as well as mention a couple of issues that we might have had with it and some mistakes we might have done during the past year that we have been using it. So starting with some context, we were in mid-2019, so this was a year ago, and we had a fairly new project using React and Redux and using Enzyme for writing our tests. Well, at this time, React hooks had been around for a couple of months, so they were fairly new. We decided to take a shot on them and say, okay, let's migrate our project to hooks. The project is new, we have time, okay, we can do it. So one of the questions that I've been asked is why migrate to hooks so much early in the process of their getting in the market and everyone starting to use them. Well, I'll give you 3 reasons in the next slide, but before those reasons, it's important to mention that the React team has publicly mentioned that hooks are the way that they intend on taking React. So being the next 3 reasons very, very important, this was also a thing that kind of was important to us. So because we decided, okay, let's jump on the hooks wagon as soon as possible, as we have the opportunity to do so. So the first reason why hooks are great in this case is code readability. So before hooks, we had lifecycle functions, and lifecycle functions are great, but often they came with the issue where that made us write grouped and run unrelated code on the same function. With hooks and with effects and the introduction of the use effect hook, now we can write related logic on the same group and write multiple effects for each block of logic. So the code readability becomes so much clearer with the introduction of hooks. The next thing is code reusability. So before hooks, we had no proper way of reusing stateful logic. Well, between components in this case. Well, at certain times at the time we had mixins, but they were deemed unsafe. And then we have some patterns like iOrder components or render props, but often these patterns come with the need for code restructuring or adding extra complexity to the code. So with introduction of hooks and with custom hooks, this now is possible and so much simpler. And the last reason here was the ease of teaching React. So at the time we knew that we would be onboarding some junior developers, and we wanted their onboarding process and ramp up to be as fast as possible, as well as simpler for them. With introduction of hooks, React became so much easier to teach because you would lose the complexity of teaching class components, the complexity of teaching how this works, the complexity of teaching how event binding works. It's important to know them. I'm not saying that it isn't. It's very important, but with introduction of hooks, in my personal opinion, React has become much easier to understand and to teach for someone that's coming into it right now. So given these reasons, we started our work. Well, the migration itself was a success. We migrated all of our class components to function components, add hooks where the hooks made sense. And at the end of it, our code was working as it was before. Our components worked exactly the same. Our code was more readable, and we had almost half of the lines of code we had before. So until someone remembered, have you run the tests? And yeah, this happened. Almost half of our tests were failing, and you could probably imagine that this was our reaction. We came to wonder, well, we did everything right? Well, components are working as they were. Our code, well, might not be the same, but the component is acting as it was. The user interacting with the component the exact same way as it was before. Why are our tests failing? And we came to the conclusion that was only one guilty party in this process, which was testing implementation details. So you might wonder, what are implementation details? So as Ken says, implementation details are the things which the users of your code will not typically use, see, or even know about. So putting this in perspective, implementation details in our tests can be things like the component state, the component props, and by tying our tests to these implementation details were the reason that our tests were actually failing. So we started to wonder, should this happen? Actually, should our tests be tied to the implementation details? We probably don't want any, well, code refactor that won't change the feature to break our tests again. And we came to the conclusion that we had the need to start writing our tests in a user-centric way. With a user-centric way, I mean we should test our components the exact same way that the user interacts with them. And we researched a little bit more about this process in testing in a user-centric way, and that's when we met the React testing library. And from the point on that we got to know the React testing library, it was pretty clear to us that we had to start using it, and this meant migrate from Enzyme to it. Well, before anything else, it's important to mention that Enzyme is great and it supplies a huge amount of tools to test your components. It's just that sometimes many of these tools encourage testing implementation details, even if accidentally. A couple of things that personally weren't working as we wanted with Enzyme in this case are things like shallow rendering. So for those of you who don't know, shallow rendering is one of the ways for rendering components that Enzyme has that will only render the shallow part of the component. This means if you have a component that has, for instance, children, when you're rendering a component with shallow rendering, it will only render the superficial part of the component and the children won't be rendered. And putting in a user-centric perspective and putting our tests in that perspective from now on, actually shallow rendering was not the way that the user interacted with the component. When the user interacts with it, it would interact with the component in its entirety. Another thing that wasn't actually going well for us was the find. The find query, the find is the way that Enzymes supports for querying for stuff on the DOM. The thing here is that it's not restrictive. And what I mean with not being restrictive is it allows you to find things by class, by ID, by component name, and this doesn't reflect the way that the user searches for things on the DOM. And last but not least, state. So as I mentioned previously, state is actually, in my perspective, an implementation detail. The user doesn't care what the current state of your component is. The user only cares if it clicks on a button, some action appears, or some spinner will appear in this case. It doesn't care if the component state is 10, is 20, it's some object, it's whatever. So as I mentioned before, the reason for leaving Enzyme in this case and going for the React testing library was actually the testing library in this case. And here we have a tweet by Ken.C. which is the creator of the DOM testing library, which is where the React testing library is built upon. And this is basically the main guideline of using the testing library, which is the more your tests resemble the way your software is used, the more confidence they can give you. So this tweet basically I read it as, okay, if you write your tests in a user-centric way, then there will be no implementation details to break your tests next time. So in this part of the talk, I will give an overview to what the testing library offers you, and hopefully by the end of this section, many of you will be able to write some tests using it. So here we have a typical snippet of writing a test with React testing library. So the first thing that we do is we import the functions that we need, in this case, the render and the fire event from the testing library React. Then we describe our test. Afterwards, we say, okay, I want to render my component, but I also want to have a way to query the DOM for stuff. So I will destructure a query from the render. Afterwards, I say, okay, I want to actually query the DOM now. And I use the function, which is the query that I destructured from above here, to get a component, to get a DOM node by using a label. Afterwards, I get that node, I fire some event. In this case, I'm firing a change event. And afterwards, I make an assert by using the expect syntax. So now I'll be going on a little bit about the functions that I used in this snippet so that you can understand what they do and what they are. So starting with the render. Actually, the render is a function that it will render your component into a container, which will afterwards be appended to the document body. This component, for convenience, returns the container in which is appended, a debug function, so that you can print its current state to the console, an unmount function, so you can simulate an unmount event, and a re-render function, so you can simulate a component re-render. Besides these things, and as you've seen on the previous snippet, it also returns queries. And queries are the things which we'll be talking right now. So in the React testing library, there are actually 3 query variants and 4 families. So starting with the query variants, we have two variances which are synchronous queries and 1 variance which is an asynchronous query. Starting with synchronous queries, we have the query by, which is a query that will return the first matching node, or if it doesn't find what it's looking for, a null. And then we have the other synchronous query, which is the get by query. This is a query that will also find the first matching node, like the previous one, but it will throw an error if it doesn't find what you're looking for. So putting these 2 queries in perspective and what the use cases might be, usually the query by is very useful when you want to assert that something is not on the DOM, because it won't make your tests fail. It won't break your tests when it doesn't find it. Going into an asynchronous query, imagine that we want to wait for a spinner to appear. Then we can use the find by query. This is a query that will return a promise that will resolve when a matching node is found or reject if there is no match. All of these variants support adding an all by for getting an array of matching nodes. So the syntax would be something like query all by, get all by, and find all by to get an array of matching nodes instead of just getting one. So a question that I've often heard is, so okay, queries have 3 variants, queries have 4 families. where should I start? What type of query should I use first? Well, you should always prioritize accessibility. And React Async Library is pretty great regarding its queries because it incentivates you. It makes you try to go on for using the queries that promote accessibility. So giving this perspective, you should always start by the order that I have on this slide. You should always start with the queries that belong to the family, that queries are accessible to everyone. Then you should go to the semantic queries. And if the semantic queries don't work, neither the first ones, you should go to the test IDs. For some any other reason, but this will probably only be useful for you 0.001% of the times, then you can use manual queries, but you shouldn't, and you'll see, and I'll show you why you shouldn't going on. But starting with the first two types of queries here. So the queries accessible to everyone are actually the queries that mostly reflect the experience of visual, mouse, or assistive technology users when trying to search for things on your page. The queries that belong to this family are the queries by label text, the by placeholder text, the by role, the by display value, and the by text. So you should always lead with these types of queries and try to go on with actually querying the DOM with them, because most of the times, if you can't use these queries, then you might have missed some things related with accessibility on your components. But if for some reason you can't really use them, then you can use the semantic queries. These are queries that make use of HTML5 and area compliance selectors. And these queries are the by alt text and the by title. These queries should be used as a second choice because the actual experience of the user when interacting with these attributes, in this case the alt text and title, varies greatly across browsers and assistive technology. So that's why they should be a second choice in this case. Now I'll show you an example of one query of the queries accessible to everyone family and the semantic queries. Starting with the by label text. So imagine that we have an input that has a label called with the text username in it. How would we go on to query the DOM for getting this input? Well, it's pretty simple actually. We would import the render function, we would render our component, and then we would destruct the query that we want. So in this case, you can see that is a query that has a get by variant, which means it will return the node if it finds it or throw an error. And then the type of query itself, which is a label text. So how would this work? What happens when I actually say, okay, get by label text username? The React Texting library will look into the DOM. It will find the label that has the username text on it, and then it will find if it's associated to anything by area labels or something else. In this case, it's associated thanks to the area labeled by attribute. Then it says, okay, so this label is tied into this input. So what the user actually wants here, what the developer actually wants here is the input, and it will return the input so we can store it in our constant. Then the use for semantic queries it's exactly the same process. Imagine that we have a span which has a title delete, and the process is the same. We render our component and we destruct the query we want from it. Then we say, okay, I want to get the query that has the title delete. It will look into the DOM and it will say, okay, this node has the title delete, so this is what the user wants, so it will return it. I mentioned previously that the user experience varies when using semantic queries, just so that you have a sense of why. In this case, the title attribute is not consistently read by screen readers, and by default is not visible for sighted users. So I hope this helps you get a little bit more sense of why this should be a second choice. If this should be a second choice, the next type of queries should be probably your last, and these are the queries that by test ID. These queries should be avoided being used most of the times because they actually reflect implementation details and the user can't see them. But let's imagine that, for instance, we have a div with some dynamic content inside of it that for some reason we want to query. Well, the other type of queries most often won't work on a div with dynamic content that is changing despite of the actions we are doing. So this is probably a use case for adding a test ID attribute to your element and querying the DOM by it. And with the test IDs, we end the part of the queries that actually belong to the testing library. The manual queries is another section of queries which is not directly related with the testing library because it actually is a query selector, the query selector DOM API. So it is not exported by the testing library, and for you to use it, you actually have to have access to the entire component and query it directly. But I'll show you an example. Before that, it's just showing a quick example for the test ID attributes. The process is exactly the same we had in the previous ones. In this case, we have a div with a data test ID attribute, where the content might be dynamic and it might be changing at every time. So this is actually a use case for a test ID attribute. The process for getting this div is exactly the same as we shown previously. We render our component, we destructure the query we want from it, and then we say, okay, I want to get the node that has the test ID custom element. It will find it and it will also return it. Once again, these reflex implementation details, and you should avoid using them on unnecessary cases. A manual query, as I mentioned, is not a query that is directly exported for the React testing library. So that if you want to use them, you actually have to access the component container in this case. And you destructure the container from the render, and then you say, okay, I want to use the query selector DOM API and get from some selector. So this is an escape hatch because it will allow you to query for things like instance as a class or an ID. And once again, this is a bad practice because the users can't see or identify these attributes. And well, when you have queries that promote accessibility and will help you write better components, then you should always focus on that firstly. Imagine that for some reason you would like to have a custom query. You'd say, okay, I want to have some query that will fit my use case. Well, you can do that. The testing library offers you a build queries helper, which is a function that will allow you to create your own queries for your own convenience. It's important that if you decide to follow this path of creating your own queries, you encourage a user-centric way to test your components and without focusing on implementation details. So by now we have dealt with rendering components, with querying the DOM. Let's see how we can dispatch some events on them. So actually there are two ways for firing events on the testing library. The first one is the fire event, and the second one is the user event library. The fire event, as the name says, will fire a single event, and the syntax is the following. We say fire event and the type of event we want to fire, in this case a quick event, and then we say where do we want to fire that event. In this case, we'll be actually querying the DOM at the same time and getting a button that has save written on it. The thing with fire event is that it doesn't fully reflect the user experience. What I mean by this is when the user interacts with a button, there will be more than a single event fired. When you interact with a button, for instance, as you have the on mouse over, on key press, and many other events just for clicking on the button. And for resembling the user experience more when interacting with stuff was the actual use case for which the user event library was created. And the syntax to using is user event. The process is exactly the same. We say click, and then we specify when we want to click. And inside of this, the React testing library, the user event library will fire all the events associated with the click. So we have seen how to fire events. Imagine that for some reason we want to wait for some assertion to pass or for something to disappear from the DOM. Here are the two use cases: the wait for function and the wait for element to be removed function. The wait for is a function that will receive a callback that will be invoked until it evaluates to true. So this is a really use case for, imagine that we want to click on a button that will eventually fire a data fetch request, and we want to assert that the request was made successfully. Well, this is if we try to do the expect API to have been called with immediately after the click, it might not pass immediately because it will be asynchronous. So in these cases, we can use the wait for. By passing the callback to it, it will run the code inside of it in a loop during a specified time until the assertion inside of it passes. If for some any other reason, imagine that we want some element to disappear from the DOM before we make an assertion, or we want to fire some event after event that element disappears from the DOM. Well, then we can use the wait for element to be removed function and pass it the element we want to expect for no longer to be on the DOM. So I believe that by now I've shown you all that you might need for using the testing library and writing your own tests, but just in case, here are a couple of helpers that have been pretty useful to me. So the first one is the within. When you do a query using the React testing library, in this case, the query will be global. The query will target the entire container where the component was rendered. So imagine that for some reason you want to run your query only inside the specific div for instances. Then that's what the use case for within is. We import the within, and then we say, okay, inside the node that we have, I want to run the query get by text, and it will run that query inside that node. Another thing that it's pretty useful, it's the screen object. The screen object was created for convenience, and it's actually a reference to the entire document body that will allow performing your queries on it. This means that we no longer need to destructure stuff after we render a component, like we did here. Now we just render a component, and then we use the screen object to query stuff directly on the DOM. And the last helper is the debug. As I've shown you when I was talking about the render, the debug is a function that will print the current state of your container to the console. In this case, you can also pass a component, a node to it, and it will print the state of that node instead of the entire state of the debug. And for convenience, it's also exported inside of the screen object. So let's jump to today. We have been using the React testing library for actually more than 1 year. And personally, I've never been happy with the way we write our tests. They are user-centric. They can survive any non-feature removing refactor. And the components that we have written so far have been more accessible, mainly thanks to the queries, because often when writing a test and the queries that belong to the queries accessible to everyone family don't work, we start to wonder, okay, are we really following all the accessibility process we need on our component? And before I get to the last part of my talk, I will just show you a couple of mistakes. I will actually enumerate them, mistakes that we made using the React testing library, so that you don't make them as well. So here are the list of the mistakes that I actually consider important and I've seen during the past year. So the first one is using ACT. So what is ACT? You might wonder. When writing UI tests, in this case, there are some tasks like rendering, firing events, data fetching that are considered as the units of interaction with the user interface. ACT was an helper created by React to make sure that in your tests, all these interactions with the user interface have been processed and have been applied to the DOM. So putting this in perspective and looking at our tests, this would be an actual use case for using ACT, right? We are rendering a component, so this will interact with the DOM some way, so we should wrap it in ACT, right? A query won't interact with the user interface. It will just get what's there. So this is not an interaction. So we don't need to wrap it with ACT. But firing an event will actually interact with the DOM. So you should also wrap it with ACT, right? Well, the thing here is we don't need it. Why, you might ask? Well, because for convenience and for more readability of your code, the React testing library will automatically wrap every function that might cause some level of interaction with the DOM with ACT. So this is pretty great for convenience. Your code gets more readable and you don't need to worry about wrapping with ACT unnecessary stuff because you would be doing it twice as the React testing library already does it. Mistake I've often seen that is quickly mitigated is using the get by query with an assertion where we assert that something is not in a document. So as I mentioned when talking about queries, the get by variant will throw an error when it doesn't find what it's looking for. So imagine that we want to use it in an assertion like this one, where we expect something not to be in a document. So running this test, if we are pretty sure that that node that has a placeholder text username won't be in the DOM, then this test will always fail. So instead, we should use the query by variant, because it will return null if it doesn't find what you're looking for, and this test will pass. Using await with fire event or non-asynchronous queries. Well, this is pretty simple, actually. There is only a couple of things in the React testing library which are asynchronous, which is the find by query and the asynchronous utils like wait for or wait for element to be removed. So waiting for a synchronous query or a quake of the event of the fire event, it's actually unnecessary. I've been asked before for some reason, but wait, I've seen some code online where the fire event has an await before. Is it supposed to be like that? That's why I use this on my test. Well, you're probably looking at the documentation for the view testing library, because that's the only use case where the fire event is asynchronous. So instead, we shouldn't wait for this stuff. Using wait for with an empty callback. So as I mentioned, wait for should be used when you want to wait for some assertion to pass. You give your assertion to your wait for function. It will loop it until it becomes true. Imagine that we have this use case when we want to assert that my mocked function has been called. Doing something like this won't make sure that your function has actually been called. It might make your test pass, but it won't always be like that, because basically what this will do internally is wait for one tick on your test and then go along to the assertion. So this means that when most of the times this might pass, there might be a couple of times where it doesn't. So instead, you should always give your assertion to the wait for when you are pretty sure that it might take some time to get there. Using cleanup. Cleanup is a function that basically will unmount your container after each test in this case. So for performance questions and issues, it might be actually a great idea to use after each test, run the cleanup, right? So the thing here is that we don't actually need it, because if we are using Jest or another type of framework that support the after each global, then the React testing library will automatically call the cleanup afterwards. Using wait for with synchronous queries. So this is pretty simple, actually. We have asynchronous queries in React testing library, so we shouldn't use wait for and with a synchronous query just to get something that we know that isn't on a DOM right now, but it will be, because we are adding more code to our test. It's not that much easier to read, and we are not using the right thing. So instead of doing wait for with a synchronous query, then we should use the actual asynchronous query that the React testing library gives us, which is the find by. And the last mistake, it's firing side effects inside of wait for. So imagine that we have this example where inside of our wait for function, we fire a click on a button, and then we expect for some mock function to have been called with some form data. The thing here is, as I mentioned, the wait for will loop the code inside of it until, well, it passes. So by doing this, we are not guaranteed to cause some harm to our tests. Sorry, but what I mean by this is we are looping our code, we are clicking on something, and when we are sorting, while this loop happens, every time the loop happens, we'll be clicking on the button. So this might cause some unexpected effects on the DOM, because we will be clicking on the button more than once for each loop that the wait for does. So instead, we should follow the approach where we click on the button first, and then we assert for our thing to have been called. Here's a thing that actually helped us catch these mistakes and, well, fight them and avoid repeating them, which is the plugin, the ESLint plugin for the testing library. It compiles the best practices and helps you anticipate some common mistakes when using the React testing library. And if you're planning on actually using the testing library, or if you're already using it and you don't have this plugin, I would definitely recommend installing it, because it was pretty great for us, and it helped us actually catch a couple of these mistakes. So before I end my talk, I want to talk to you about a warning that I've often seen, and people often freak out a little bit when it happens to your tests, and that is fairly easy, which is an update inside the test was not wrapped in act. When testing, code that causes React state updates should be wrapped in act. So I'll give you an example so that you can understand what's the use case for this warning, when does it appear, and how can we fix it. So imagine that I have this component called display Pokemon that will receive a function to get some Pokemon data. This component also has some state for if it's loading or not, and then we have our function that when it's called, it will set as the loading as true, we'll wait for the get Pokemon data, and then set this loading as false. Or if we have an error as well, set the loading as false. On the return part, we have a button that when we click it, we'll call the get selected Pokemon function with Pikachu in this case. We also have a span here to check if the component if it's loading or not, and display to the DOM loading or don't display anything there. So how would we go on to test this function, the get selected Pokemon function? We'll probably write a test like this, right? We'll say, okay, I want to render my display Pokemon component with a mocked get Pokemon function. And then I would say, okay, I want to click on the button that has the name Pikachu in it. Afterwards, I would assert that the get Pokemon data has been called with Pikachu. So this makes sense. We are testing the full or the entire flow of getting a Pokemon, right? The thing here is when we run this test, this will happen. Yeah, the dreaded warning. An update to display Pokemon inside the test has not been wrapped in act. So if you remember the part where I spoke about act should be used when we are causing some state updates or something that will interact with the UI. So what are we missing here? We are testing our get Pokemon data function. Looking at our component, we are apparently not missing anything. Well, the thing here is we are. This warning is there to tell us, hey, look, your component, your test is working, but you are causing some state updates after or some unexpected state updates. Your DOM is rendering and you were not considering that in your test. So this is the way that React actually found to tell the developers when we are testing something, hey, look there, you're not testing your component and it's in entirety and you're missing something. So what might we be missing on our test that we didn't consider? And yeah, in this case, it's the loading. After we call the function, we assert that the get Pokemon data is called actually, but we forget about something. We are also setting the is loading as false. And this means that afterwards, our component will re-render and will cause the change from the is loading to disappear to an empty string. So first of all, we have to thank React for warning us, hey, you're not testing your component in its entirety. You're forgetting something that happens. You're forgetting something that happens that's actually changing your component state in what you're displaying. So how would we go on to fix this? Well, in this case, it's pretty simple. We just have to assert that either the loading is not there by using the wait for with an assertion. In this case, a query by text query that will get if the loading is there, and assert that it's not in a document. So this will loop the code, and until this query by text doesn't return null, it doesn't get out of there, well, giving a defined time. If we don't want to follow this approach, then we can use also the wait for element to be removed and wait for the loading to disappear from the DOM. Either scenario is fine. So just a quick recap, and so that everyone has this in their minds afterwards and when going on to test their components. This warning often appears when you're forgetting to test something on your components. You might think that you are testing everything, but there is something, a request or some state update that you might not be considering. And for those of you who might have these issues right now, I invite you to look at your test, look at your component, and try to find some state update, or something that will trigger a DOM change that you're not considering in your test. So I guess this was a wrap. The main takeaway I hope that everyone takes from my talk in here is that actually the issues was not the React hooks. The title of this talk is quite misleading. The React hooks didn't break our test. Implementation details did. And thanks to the React testing library and to its guideline, and by following along and writing tests in a user-centric way, we made sure that that didn't happen anymore. And personally, I've started enjoying writing tests through. So thanks to the React testing library for that. I hope everyone enjoyed, and I want to thank React Global for having me. So that's it.
Thank you, Daniel.
Thank you.
It was really interesting to listen to you and to your presentation. And I'm glad to announce you a Q&A, the last Q&A session. So, guys, you are a hero. I have no pressure on you. You can just enjoy your time, just rest and talk about your topics, because actually we have just a few questions to you. So if there are some information that remained unrevealed on you, or you thought that you have no time to talk more about your topic, to continue your speech, you can use this time and you can tell more. So the first question is, wait a second, I'll find it. Actually, I have lost it. Richard, we've got a lot of compliments about your speed. Once again. So the first question is, what the plugin you use to leave preview to console.log?
So that is a plugin called Quokka, Q-U-0-K-K-A. I'll just briefly share my screen so for context for those who missed my talk. But it lets you kind of, so for example here, I'm trying to test whether I've updated the state. By wrapping it in a console log, then Quokka does a live preview. So it's a great VS Code extension. There's a community and a pro edition. I just use community. I haven't tried pro yet. And community's free.
This is kind of compliments we've got about your speed. I just can't miss this. So the next question is, what the extension you use to show the correct error syntax, something like green square, a white square, yellow square in your VC code?
So what that is the combination of two things I think you're thinking of. So it's firstly, that is also comes with Quokka. So when you, so I think you're talking about the sort of like green squares, red squares like this. So if I like make a mistake here, for example, or let's miss it out. I think that'll probably, there we go. So I get the Quokka gives me a red square, which shows me that I've made a mistake. I'm also using TypeScript. So Quokka you can use with JavaScript or TypeScript. And it's a combination of the two together, which gets like really helpful error messages.
Thank you. And the next question also is addressed to you. Where we can find this Reduce state management? So
it's an NPM library. So you can add it to your projects with NPM install Riduce. That's R-I-D-U-C-E. And there's also like a GitHub repo under my like personal GitHub. It's pinned. So if you check out my profile on GitHub, you'll see it.
So I'm looking for another question. If there's a pattern, you can just make it iterative.
I think that was actually the answer to an earlier question. I believe that was about my storybook example code, where I showed 3 stories. And there was a question by Leon asking why not make a function with a for loop instead of writing 3 stories. Well, which makes sense in this context, because the example showed the same button with the only thing changing was the appearance prop. So yeah, you could write a for loop and like create 3 stories in the loop, or have it iterate an array or something like that. That can only actually be done by using the legacy stories of syntax, which is the way that you used to write stories in Storybook. Nowadays, with a thing called CSF, component story format, which is what I showed, that's no longer possible, because you can't do that. You can't have an export inside a for loop. It's not possible with ESM. But what you can do is use Storybook args. If you Google for Storybook args, you'll find it. It is a newly added feature in a recent version of Storybook, where you can have basically a prototype, or say a blueprint of a story, and then dynamically inject various properties or sets of properties in their args. So that's the way that you would do it.
Thank you. And the last question is, do you have any way to automate component hook testing, React testing library?
So, yeah, imagine that usually when you create your custom hooks, or you have some hooks, usually if you follow along on your test and actually do the scenarios the user will do them, actually the user-centric perspective, as I mentioned during my talk, most often you will have the necessary coverage for testing your custom hooks in this case. But imagine that for some instance you have a custom hook with some really complex logic. Then there is another testing library, which is the React hooks testing library, which allows you to fill in for actually these hooks, custom hooks tests, and that are often more complex. So yeah.
And I found another question on Pine platform. Would you recommend, as a rule of thumb, keeping your logic outside of hooks, mostly as pure functions, so that it can be tested more easily?
So personally, what I do is it actually depends on the context that we have. We might have some hooks that, imagine, you can create some business logic and some hooks that could be done, but most often the process here is try to keep the hook without logic, depending on the case in itself. Yeah, sorry. Let me go back a little bit. It depends on the case itself. There might be cases where you might need to add some business logic on the hook. Imagine that you have a really specific use cases where you have your internal API that you think for some reason say, okay, I want to create a hook to get the data from this API, make some transformations to it. Then this is probably a great case for adding logic inside of a hook. For many other reasons, if you want to create, for instance, just a custom hook for getting data, for doing a GET request, then this is a use case for making a generic hook. It actually depends on the use case you're dealing with.
And the next question is, providing my goal is to have a user-centric driven tests as possible, why should I choose React testing library instead of Cypress?
Well, you could use them both. Personally, I really like React testing library for writing my unit and integration tests, and focusing more on Enzyme for end-to-end, because they can complement itself. There is actually a testing library for Cypress as well, which is the Cypress testing library. So in a short answer, I personally like React testing library for unit and integration tests, and Cypress for end-to-end. So you can use them both at the same time.
Great. And what is better approach to test components which are updated through sockets?
Sorry, I didn't catch the last part.
What is better approach to test components which are updated through socket?
Well, personally, I haven't written any tests while using sagas, but I'm pretty sure that the process could be almost the same. Usually do some action and you wait for something to appear. Imagine that. I'm not really into all sagas work, but if for some reason it will derive state or get state from somewhere, usually by firing some action and waiting for that action to reflect on the DOM being true in a state update or something, might allow you to assert the saga's behavior. So you don't need to be agnostic to the framework you're using. You shouldn't focus on the framework. If you focus on it, well, going back again, as the user interacts with it, you'll probably be safe enough from what type of technology you're using back there.
Thank you. And Stefania is asking you, how can you start implementing a visual regression test in startup?
So regarding regressions, there are usually a couple of tests that I do. You can, for instance, as when you have the first type of your component, you can do a snapshot test. So it will generate a snapshot of your current component. And if for some reason it breaks on an next iteration, then the snapshot will actually tell you. If you don't want to use snapshots, then you can write just a query to assert that the things that you want are in the DOM. And if for any reason you remove that component on the next iteration on your implementation, then it will definitely warn you.
Mm-hmm. And for this time, might be the last question from Rustan. When should I need to use React testing library, Chest, and Keepers? Why testing really important? It's make us write more code, right?
Yeah, it actually makes you write more code, but it will actually help you sleep better at night when you have code in production. So I hope that anyone in this Q&A panel can share their opinion on this. I've had so many tests catch some bugs, some unexpected bugs that we have, and well, thanks to Cypress, to the testing library, and the automatic tests that we have that run either on our pipeline or our development environment, we managed to catch these issues before they get to production and getting to the end user.
Absolutely. I think, to be honest, what I usually say to people is there needs to be usually around a 3-to-1 at least ratio of test code to production code. If you're don't cut corners on tests, because like as Luca and myself as consultants, whenever we used to go into companies, the first thing is, where's the tests? And the tests aren't there. So people get stuck they paint themselves into corners, and then they say, right, we need to change X about this thing because it's this, whatever X is limiting us. And we go, right, okay, where's the tests? And they go, and so then the first thing you have to do is write a bunch of tests before you can even make that change. So if you don't write tests, you can't be flexible, you can't move quickly. And the whole deal is make it so that you can move quickly, then the business can move quickly, which means it can be more competitive in the market. So if you don't write tests, you're not competitive.
Basically. I would say there's actually two fallacies in here. For one is like the question being asked, why is testing really important? Well, business reasons. Businesses don't want downtime, right? And you get downtime if you like ship broken code. You just explained it. There's a huge business case for that. Of course, it differs from business to business. If you're just like getting started, you want to quickly iterate, like move fast and break things, but like big enterprises don't do that. The other fallacy is, I would say, like the question is, like, doesn't it make us write more code? Yes, it does, like 3 times as much code. But let's be honest, I write maybe on a daily basis, I'm writing code for about 30 minutes a day. And that's it. And I don't have to write more, especially if you type as fast as Richard here. Then, I mean, he's probably done with his job in 15 minutes. The other thing is the other 8 hours you're spending thinking about things, all the various edge cases and scenarios. So writing more code isn't the problem. reading code is actually more of an issue. So if you write your tests in a good structured way, actually what I do is if I'm unfamiliar with a code base, I go look at the tests, I read the tests, and I know what all the edge cases are that have been considered for this code. Because if they are there, the tests, then that's a very solid basis to like continue working on that. It's like the best specification you can have. Even better than the actual source code.
Well, not only, right? So, I mean, Dave and I made a huge career out of saying, write a unit test is better than an email, right? In open source, in any kind of, even you know, I'm not a believer of move fast and break things without a test, because that one is already kind of avoiding to break things, right? And so I think tests are mandatory, right? There is no excuse to not write a test. Just I mean, in my daily job, if somebody doesn't write a test, I don't even look at a PR or anything.
Yeah. Well, maybe if you're just prototyping something, right?
But you can write a unit test. You can write a test, right? A test is already a prototype, right?
Well, that's actually a funny thing you bring up about prototyping, because the people can get very locked into the idea of TDD, test-driven development, and they sometimes think that means you have to write the test before anything else, and that's not true. The key part is that you write a test at some point. In prototyping, what we do is if someone is prototyping something and they want to have another set of eyes on it, then they do it as a draft PR. But so that means we're not looking at merging at all. We're just having a discussion. But we're not going to consider PRs that are asking to be merged with our tests.
Yeah. Well, I find that.
Right? Oh, sorry, go.
Sorry. So in terms of writing tests, you do write more code, but I find it improves my developer experience actually, because if I have tests, then I can confidently make changes to something and know that I'm not going to break anything because I can check against my tests. If I don't have tests, then I'm really afraid to write code. So I'm like, what if I write this and it breaks something? So it's good for you if you write tests.
Can I just throw a grenade into this? I think this is partly the appeal of TypeScript for some people, that they feel safer because of the types, but it's a false sense of security. You need the tests. I'll just let that hang there.
It comes from, I mean, don't get me started. It comes from not knowing what a compiler does, not knowing what a strictly typed language does, right?
I think the term type safety has done a discredit to a lot of people.
Yeah, sure.
I would say
like JSON schema.
TypeScript guards against various things that you technically could write a test for, but nobody does, right? I don't write a test to check if something is a Boolean or a string, right? Even if it's vanilla JavaScript. Your tests are meant to describe what the hell your app is supposed to do in which scenario, or what this piece of code is supposed to do in a particular scenario, right? Describe it, like given, when, then, that works as a very good model, right? If you follow that properly. I just read the descriptions of the test, not even the implementation of the test, the description of the test. If those make sense, I know a lot about this code.
Well, this is another thing, and it's not something that really gets covered a lot, which is test code as communication, because we've covered it all from the perspective of production safety, market competence. But yes, it's a good point. The test as communication is key, but that can also be problematic because the skill of writing tests is not necessarily the same as, say, prototyping. It actually comes with the ability to, if you're good at writing a blog post, you'll be pretty good at writing tests, more than if you're like good at writing assembly code. Does that make sense? So yeah, I agree with that. I think on the testing a Boolean thing, though, I do write tests that way. I mean, the thing for me is 100% coverage is in no way a panacea, but when you hold yourself to 100% coverage as a standard, you make sure you're getting every conditional check in your logic, and it can tease out other problems. But it's also important to realize that 100% code coverage is in no way 100% case coverage. Another thing that we've employed in the past is fuzz testing. which if you're not using a type system with TypeScript, for instance, like fuzz testing is a real great one for teasing out potential problems with, you know, really crazy inputs. You can just like leave there's when someone else is talking, I'll look it up. But you can basically leave a fuzz tester running overnight, and it will find new problems in inputs to something. And then there's a fuzz tester by Matthias Boo's Macintosh that actually will write tests for you based on failure cases. So it's a really cool thing. I'll look it up while the rest of you keep on talking.
It's 11 hours.
Oh, guys, like I'm just enjoying your speech. You're so awesome. And by the way, thank you so much, Luca and David, that you joined our Q&A session. You didn't have to, but anyway, you joined it, and we appreciate. Like, I personally appreciate it so much. Seriously, like, you're very sweet.
No worries.
And we have 3 new questions for you. The first one is, what is the better way to manage easily the state of our React application, Redux, or use Reducer, React Hook, or GraphQL?
Well,
I don't know how to pronounce
that
it correctly. You can fix it.
Yeah, that's a great question. I believe we all have iterated of this type of question once upon a time in our lives. But from my opinion, actually, on this, it really depends on your context and what type of application you have. Recently, personally, I started dwelling with the difference between server state and client state. Actually, I've started using recently React Query. It is pretty great for dealing with the server state. And on the current project I'm in, we started with Redux, then we migrated to context because we found that using Redux at the time was like using a bazooka to kill a mosquito, basically. And then when context was becoming not scalable, we found React Query to manage our server state and continue using context for managing the UI. So I guess here it really depends on your application and on the type of app you have and your experience, actually. This is a really relative question. Really depends on the...
Yeah, I totally agree with you on all of that. The experience is the key thing, because there's been times where we've gone with Redux just because now it has a lot of mind share, and it has the documentation and, you know, the diagrams that explain the model, the sort of the data flow. But you can totally achieve the Redux pattern with Use Reducer. And if it's a small enough application, you should. If it's a larger team and you don't know if anyone's going to be rotating on and off that project, then it's possible that you should use Redux. I think what would be really good is documentation of the Redux pattern as a separate thing, and then people could just use that. A lot of the time these days, we're trying to build libraries and frameworks to solve problems, but the libraries and frameworks are often manifestations of patterns. If we describe patterns, particularly in cases like this, it would be more useful, but there would be less, I guess, less street cred, I guess. You're not going to get as many GitHub starts for that. But it needs a sort of Martin Fowler type person to do something like that, I guess. Luca, you could do it. You're a Martin Fowler type person.
Yeah, I order his T-shirt, right? So now I can. No, but I mean, there is just one uninvited guest in this question. That is GraphQL. Currently, it's not in the equation of state management, but I agree with kind of, you know, Dave, with your point, but at the same time, you know, I think the biggest problem right now is that we are so tightly coupled with state management, right? The state is becoming the elephant in the room every single time that you build an application. It's always about, before it was getting Redux and dragging basically like some useless kilobytes with you and some extra headaches. And then, finally simplified with hooks. But, I think the final state will be to try to decouple completely state management from the front-end application and try to lean it out as much as possible.
I mean, that's not just true of front-end though, is it? That's true of
in general, from any client to server.
Yeah, the trend these days is entire systems are going towards isolated data management, and when you see bloat in the client part of it is because the data management isn't there in terms of like the entire organization.
True, but because we are coming from the data binding kind of world, right? Just look at history, right? We come from ASP.NET and data binding and having the front end couple with the data source, right? That's where it comes from. So that's why this decoupling is historically kind of very hard, especially in enterprise, right? In enterprise, you will always hear that your front end is tightly coupled, its state is tightly coupled with the model that you are trying to represent. If you think the larger the organization becomes, basically you are dragging probably the size of a movie every time that you open a web page to just get 3 properties, right? And the complexity, and that's why I think GraphQL represents a huge transitional state from, fully client-side or server-side to a hybrid state where, href and Atheos API, they try to handle that, but the GraphQL takes it to the next level, right?
Well, I mean, the problem with GraphQL is its application level joins, and this is typically what should be done in a database, but it's a plaster or a band-aid for organizational dysfunction, logistical complexity, the fact that teams are distributed. GraphQL tries to bring that back together, but then you end up with a new problem.
A single point of failure.
Again,
yeah. Right? That's the biggest. The problem is that even micro frontends, and you and I kind of saw this problem since even its inception, right? State management in a micro frontend is even a bigger headache, and when you go into hybrid kind of micro frontends, it becomes even more complicated, right? So we try to solve it with local storage, right, and then play basically the game of rewriting whatever database on the client side, because you need to merge state between different applications that they're isolated, but they need to interact, right? So I think state management is a very complicated problem to solve in an elegant way. It will always be dirty.
Yeah, but in the front end, the reducer pattern is very effective and also great for debugging. Making all your state changes in one tick or in one call stack makes for much easier problem solving in the future. The original Flux pattern being asynchronous made that difficult, and what Redux brought was we were talking earlier. We were saying what React brought was componentization. What Redux brought was state flow, Flux-like state flow in the same tick, which we don't need Redux for that anymore. We can use Reducer.
True, but at the same time, you basically you are adding a facade to handle some sort of process side, right? But the concept of state management is still,
as a larger topic, it's very difficult. Yeah.
On Reducer, Redux versus use Reduce, I think something as well which is worth thinking about is exactly like David said, there's a common pattern of Flux architecture, which is really worth understanding. In terms of things you might want to be aware of Redux, with React concurrent mode, I think Redux maintainers are currently kind of trying to solve this problem, like how is Redux going to support that? And they think they will solve it, but they haven't got that nailed down yet, I believe. Whereas use Reducer, obviously being, because it's kind of part of React Gateway, is going to play much more nicely with concurrent mode. And if you understand the kind of Flux architecture, the pattern, then you can use either as well. So kind of rather than sort of being like, I'm going to learn Redux or I'm going to use Reducer, thinking about the kind of what's actually the kind of Flux architecture, and then you can just pick whichever.
So guys, sorry for interrupting. because we have four next question to discuss. And Harshit asks, can you guys share your experience on the mistake, learning you did, found out in your initial coding development days? This is quite interesting question.
Who wants to go first?
You choose,
Let's go
guys.
from the oldest to the youngest, so that we a journey through history, right?
12 years.
We don't have the bio, like that big bio of yours. So choose by yourself.
I can
actually
start.
think you're the
Probably I'm the
oldest.
oldest.
Yeah, I think you are.
Thanks, Dave. Thanks, Dave. Really
I'm
appreciate it.
nothing that.
So I think the biggest mistake was over architecting and forgetting about simplicity. So mostly from a mental model, over architecting the solution, and creating just a self-convoluted application like this monolith React app that resembled mostly of a JSP application more than a modern application. If you look at basically just React as kind of the starting point for mistaken learning. And the biggest learning is basically what Dave and I talked about, right? The simplification down to the essence of what React is, that is just a component, and just try to use it as it's primitive.
What's interesting is I'm the opposite of that. In the early days, if you might be familiar with Occam's razor, which is you want to make something as simple as possible, but no simpler. My mistakes more in the early days was not thinking through things enough. So I would under engineer rather than over engineer, and that's why Luca and I work well together, because we pull each other towards that sweet spot of simplification. My main mistake, and still one of my big mistakes that I make, is underestimating the the enormity of the project.
I can attest to that. Everyone does that, right? Like, my general rule of thumb now is like, okay, I come up with an estimate, and then I double it, and then I still know I'm probably gonna have to double it twice more. It's just, that's how it goes.
If you didn't think like that, you wouldn't start. That's the problem.
Yeah, that's true.
My main learning is probably that, I mean, it may be relevant to kind of, especially with you kind of audience having just watched like a lot of great stuff, is like make sure you actually like go and do things. And because I found that I always learn the most just by trying things out and by making loads of mistakes. I mean, like, well, this doesn't feel right, you know? Like, I've been doing something, but it's so painful for me to change things. Like, I must have organized this incorrectly. And then like just that sort of like allow yourself, give permission, just try new projects, just pick things up, and kind of don't make the kind of mistake of kind of like, you watch something, great, I watched it, awesome, now that knowledge is in my head. No, you've got to actually do stuff with it and actually like learn through experience.
Yeah, personally, I really agree with that. And in my perspective, one of the things that I think that I really liked when I started coding was actually the curiosity of knowing how stuff worked underneath most of the times, because we can get lost on the small description of what stuff do and be like, okay, I see the snippet on Stack Overflow, I copied it here, I paste it here. But most of the times, if we don't get into it and we don't understand how it works, if we don't make those mistakes, actually, I wouldn't get where I am today, because really I would just get lost in like the shallow part, and being more curious, trying stuff up, really understanding how they work, why they work, what are the use cases, really helped me into growing.
So the next question is, would you suggest focusing first on services and utils coverage and leave components as last step, because components are easier to test from a user perspective during QA? Like, this question to all. I can repeat. Would you suggest focusing first on services and atlas coverage and leave components as a last step because components are easier to test from a user perspective?
I think what this person is saying is, and correct me if I'm wrong, anyone. Let's not worry about testing components and let Q&A catch it, because it can be caught from a user perspective. You could even replace that by saying let end-to-end test. It's kind of a question around end-to-end. Should we do the question? Let me rephrase the question. The question might be, should we unit test components? And if that is the question, the answer is yes.
Yeah, I agree.
Because you could apply the same logic to services. You could say, well, the services can work. You can end-to-end test through the services as well. So, like Q&A and end-to-end testing are known as high fidelity or high resolution testing. And with high resolution or high fidelity comes increased cost. The cost of maintaining E2E tests is way higher than the cost of maintaining unit tests in terms of your time and effort and all of that. So unit tests are cheap, but very effective. And you can use like React Shallow Renderer, or I guess you guys have been talking about this already, to isolate components and render them and test that they at least create the right tree and test their behavior. So yeah, I don't not test components. Test components with unit tests. When it comes to end-to-end testing, just on a side note, that is a very expensive thing to do. So I've seen projects write end-to-end tests at the beginning of a project, and it was worst decision of their life. You have two scenarios when you do that. You either have a ridiculously high investment in end-to-end testing being constantly updated as the application changes, or they abandon end-to-end testing and are so traumatized by that experience that they don't actually do it at the end of the project. So wait until you're about 90% done before you write any end-to-end tests.
Mm-hmm. And the last topic would be the dev tools for Redux is great. How is it with Context-DB? I can repeat it. The dev tools for Redux is great. How is it with Context-DB or context?
With use reducer and context and so forth. I actually don't know the question. Anyone else? The answer to that.
You can just use the React dev tools. You can see what's the current state and such. You don't get things like time traveling, I believe, but other than that, you can just inspect the DOM or the React component tree and click a node and then see what's the state at that point in the tree.
Actually, yeah, in the early days when we were migrating to Redux, I actually found a project. I'm not sure if it's being maintained as well, which allowed you to tie in the use reducer to the Redux DevTools. So you would actually be able to use the Redux DevTools to check what was the current state. But I'm not sure if it's been being maintained anymore. But it was really fun at the time.
Yeah, I used it for React Native, and I think they stopped to maintain it like literally 2 weeks after that we started using it in 2016, something like that. 17, sorry.
Yeah, I think there might be maybe a more recent library for it. I have seen something which I haven't tried myself, which promises to plug your use reducer into some kind of like nice debugging tool. I haven't tried it myself, but there will be something out there I'm sure you can find.
A nice console log everywhere. Straight into the source code console log.
Never underestimate console log.
It always works.
After 12 years of software development, I still write console logs all over the place.
Every single time.
I know how to use a debugger, I just don't.
I can't use a debugger. Just like I if it's not a LLVM, I don't use it. So console log it is. And you need to be very creative, right? Because then you start designing your own, your own graphics, right? 1 dash, another dash, 5, and then you start drawing things.
Mhm. And next question would be how to store multiply files into Redux state.
First question is why would you do that? I can. There might be some situations where you would do that, where you're doing uploading or something like that. But yeah, I mean, I think you can probably put them into blobs, or you can encode them into as arrays in byte. You can either just use a normal array of numbers that represent the bytes. There's lots of ways to do that, and the more general question is how do you, to answer that question, I think the best thing is to just look up how to store files in JavaScript, because it's the same kind of thing.
Most likely you just want an array of strings, right? It's just a URL or something to the image. Like typically,
well, preferably, yeah. I thought they were talking about the actual contents of the file.
Yeah, it's kind of unknown, but yeah, if it's a blob, I wouldn't even store that in Redux. I think like just raw data. I would always store a reference in Redux to the file. And that can be a URL or something like that. Typically, I would just upload it directly to Amazon S3 and then have a URL to the S3 bucket, right? The file in the bucket.
Yeah. And I wouldn't even kind of frame this as like a Redux specific question. So it's like, there's a question like, how do you represent these files? Maybe it's an array of strings. Separate question, are you going to put that representation in Redux? Are you just going to keep it somewhere like in like a local component state? You know, so it's not a sort of like, Redux isn't a sort of like, right, like there's something special about storing things like in Redux. It's like you represent your state, and maybe you use Redux to kind of store your state in, maybe you don't.
So guys, I will announce an end of Q&A session. And I'm too grateful for you. Seriously, you are so great speakers. And I'm really I'm happy that you decided to become our speakers for today. That was really warm conference. I don't know. I'm too grateful. So thank you. Thank you very much.
Thank you
for having us.
Yeah. Thanks, everyone.
Yeah, have a good day. And some of you have a good rest. Especially you, Luca. Good night.
Bye, everyone.
Bye. So, guys, that was such a great conference. I just couldn't imagine that it would happen today. And I would like to remind you that you can buy all the records from Junior Track on our webpage just for $15. So, and I'm eager to announce you about our future events that will be held on October and November. So we see a global mobile development community as one big house with many rooms. And this time we want to cover one of the rapidly growing trends and open the door to cross-platform development with Flutter and React Native to everyone interested in these technologies. So we'll be running this summit in October. So please check it out on our crossplatform.geekle.us. And with this promo code on the screen, you can get 20% of discount. So don't miss this. And also, we are excited to invite you to a unique event that will bring together two worlds of cross-platform development. Our organizer are dancing just behind, so I even can express how happy they are. So here's our mother of organizer. Oh my God, we are extremely happy because this conference was the greatest. I don't know, all the speakers, they were awesome, and Gant, my heart is melting. You are amazing. So where I ended. So the summit will take place on the 13th of November. And yes, it's Friday 13th. So our speakers will share with us the latest news from Flutter and React Native worlds. We're extremely proud to have with us contributors from both communities and developers from top brands. And also, the Python community needs the platform to share the latest updates and use cases to improve coding skills and to get architecture insight. So we are going to provide you an online event for Python Geeks on November 19. And with promo code on the screen, you can get 20% of discount. And the last one is going to be Python Universe Web Additional Global Summit. Is going to be an outbreak event with speakers from famous companies like Netflix, Facebook, TikTok. And our Google speaker, Deborah Cornella O'Brien, is going to tell how Python changed her life and gave her a position at Google. And the speaker from Netflix, Harrington Joseph, will expose problem scrolling services of dealing with complex architecture. So please don't miss this date. And guys, like that was a great pleasure to share these 8 hours of the coolest conference ever. Seriously, ever. That was so great. Like, I don't know. I'm going to cry. Jen is also going to cry because she organized all of these like details and stuffs. So I hope you enjoy a lot. And as usual, don't forget to wash your hands, to be safe, and please follow us and don't miss our future events. So bye and come here, guys. Yeah! Woo! Bye!